Hello everybody and welcome to Handmade here, a show where we code a complete game live on stream. I left some windows up from the pre-stream. I don't really know why. I don't even know why this was up here. Probably just because I was showing some Windows stuff, and so we needed to launch the game. I want to start out, but in the pre-stream, Kim Jorgensen, and I apologize if I pronounced that wrong, it might be Jorgensen. I'm always wishing that I got a pronunciation guide with everyone's names so I could get them right. One of the downsides of the internet, like I feel like Twitter and Twitch and stuff should have a little what's it called? Like one of those little speaker icons on there, where you could just click on it and it would have them pronouncing their name how they wanted it said. So that would be a nice addition. But anyway, he is asking for Linux change. He said there's a small compilation error with Clang that says extra tokens at the end of the endif in handmade import.cpp. This is probably something that Windows that we compile with Microsoft compiler normally on Handmade Hero because we started with that. And Clang couldn't really compile stuff for Windows when we started. It can now, so we actually could use Clang. We maybe should add a Clang step to just compile to make sure it compiles properly. But point being, it probably is something that the Microsoft compiler should also be complaining about, but doesn't because it's a little bit more permissive. It's probably not supposed to be there. So I'm just going to go down and get rid of that for people who are compiling it. Oh, yeah, you can see. Oh, wait. No, I can't see. Oh, there it is. Yeah. So I don't know what that's doing there. I'm going to get rid of that. And then I think we're good to go. I suspect that was the one. I hope that's the... Is that the right one, Kim? Just tell me thumbs up or thumbs down. Was that the only one we needed to remove for the... Yes, okay. So I just want to get rid of that at the outset of today's stream, just so I try to keep it the code base fairly clean, so that people who are trying to compile on Linux or Mac or other platforms don't have too much trouble. Since we don't do those on stream, if someone wants to follow along on those, it helps to just clean up whatever we're working on to make sure that it behaves properly and under those circumstances. All right. So at the end of the previous stream, I wanted to start working on some entity storage stuff that would sort of be a larger set of information for entities that were sort of in the important set that would then go away afterward, but that still persisted frame to frame. And so I want to do that, but while I was doing it, I was like, I'd really like to show the memory usage here so that we can be cognizant of it. And also just so I can point out why there's some reasons why we want to consider doing this or why it's important for us to do this. And so just looking at how we had our stuff set up, there was really no way to track memory allocations because we didn't really, we really just didn't have a way of saying, hey, here's the stuff that's currently allocated. And so if you take a look at our memory system here, I upgraded it so that now every time you call push size, which is pretty much our only thing that allocates memory in our system, there are a couple other things in the platform layer that will occasionally do it. But in terms of the actual running game, more or less everything we do goes through this push size call. So every memory allocation we care about looking at, it goes through that. And inside the push size call, where you've got internal memory param here, what we're doing is we're saying when we compile in Handmade internal mode, what we're going to do is pass a file name and line number to the push size call so we know on whose behalf the size was requested, that amount of memory. Now, the question is, so at this point, thanks to yesterday's stream, we have it so that is happening. Right? Meaning we're getting all of that information. But once we get into the push size, we don't do anything with it, right? So we don't actually have any way of using the information that we're actually getting. And that creates a problem for us because now when we want to go print it out, printing it out at the time we do the allocation doesn't really help us. We want to be able to print it out at a specific time when we go to, say, draw the information about what's in this arena. And so there's a couple different ways that we could really do this, but what I'm assuming the most efficient way for us to do it would be is to just sort of have this information get stacked up inside the debug system somehow. And so I'm going to just make a system for doing that explicitly, and then we'll kind of figure out how we want to massage that later. Now we have one issue, which is that our memory arenas themselves, probably when you actually create one of these arenas, so, you know, you can see in here where we actually do a like, all right, if there's a current block or not current block, these sorts of things. When we actually go through and use these arenas, I don't think you actually have to do anything to make them actually work, right? So if you just have an arena that's just got nothing in it, if it's just zeros, then what'll happen is when you first go to use it, it'll just start allocating some memory for you right there. Because here's the call, for example, that allocates a block for the arena to start using. If you just pass an arena that's just garbage, like zero, it's completely zeroed out, it just starts working. So it's one of those zero is initialization patterns that I like. And so we want to preserve that. What that means is that when we actually record these allocations, we do sort of have an issue, which is we don't necessarily know how to talk about what the arena is. We can use the pointer, so we could say that like this arena pointer is the thing that we are associating these with. And I think, unless I'm mistaken, that's probably the best call. Because if we don't do that, I'm not sure how else we would really identify them. We don't ever have a place where we specifically name arenas, and I don't really know that we necessarily want to either, right? I think what we want to do is just say, look, this is the pointer to the arena, and here's all the allocations that it had. Now, one of the problems that we're definitely going to run into is that those pointers, those memory arena pointers, may not be stable, right? And what I mean by that is that obviously arenas come and go, so we can't really count on that arena pointer pointing to anything specific. I think that's probably okay. As long as we track arenas by pointer, we should still be able to record what happened to them and show it later, just by associating them as if the pointer was a name. And since arenas have to be properly freed, otherwise it's leaking memory anyway, which is something we would want to see, we shouldn't really have to care about whether that arena pointer is A, still valid, or B, getting reused, right? Because you should have had to have called things like free all memory or whatever, right? Clear, right? We should have had to call things like clear to get rid of the memory before we reuse the thing anyway, or before we get rid of it. And so, you know, we don't really have to worry about use after free of the pointer, reuse of the same memory location, but for a different arena, because we can actually just think of that as the same arena that just got cleared. So there's no real downside to using the pointer, I don't think. So mostly what I would like to do here is just say, okay, let's just say that what we're going to do is create this allocation here. And what we're going to do is we're going to say that when we get to the end of it, we're going to say like debug record allocation or something like that, right? We're going to have some call that we make. And that's what we're going to pass. We've got that file name and line number that, again, are coming in here. And we need to give it some information about what actually happened. So you can see here that these are probably the two things we need. This is the amount of size we allocated, and this is where we allocated it. But the other thing that we probably want to do is we may want to record how much size was actually used. Because, again, because of alignment, we may be allocating from the arena more memory than we actually needed, and that may be something that we want to do as well. So an allocated size and then the amount that we used, those two things are probably important as well, just to make sure that we can see that waste, that is essentially waste. And so it's nice to have that in any given block, you know, how many bytes did we waste? It won't matter for large blocks because who cares if you waste a few bytes, but for small blocks it could matter if we're looking and we're seeing in a thing that's like, wow, there's a lot of like wasted space there. Maybe that's important, I don't know. So if we then look at how this thing would work, we'd say, all right, we've got the file name, we've got the line number, we've got the allocations, how much they were, how much we used. And so what we want to do is we probably want to give it the necessary information to do a good job tracking this. The arena pointer, like I said, I think would be good. But the other thing that might also be good is since we know that we're allocating out of the thing called the current block, and that current block has a base pointer, what we might want to do is say also, in addition, here is the base pointer, right? So we're basically saying, look, here's the pointer, if in case we want to associate things together as parts of individual chunks, we could say here's the base pointer. In fact, we could even give it the whole block structure. If we go, if we go and look at the memory arena here, you can see that this platform memory block is going to give a lot of that information. What we could say is like, look, maybe we give it the entire thing so that the debug system can look at that that block and know all of the stuff that's involved in it, right? So if we recorded all of these information, all of this information, we'd be in pretty good shape. But we also need one more piece of information, which is that will only tell us when things are allocated. It will not tell us when things are deallocated. And I think what's important to realize is that we can do a good job of tracking this through the debug system by recognizing anytime we free things in an arena, we are freeing them in one of two ways. Either we are rewinding a block's used pointer, or we are getting rid of the block entirely. And so if we take a look here, we could do this. That tells us that this entire block got removed. And similarly, in anywhere where we rewind, which I'm pretty sure there's only one place we rewind, which is in end temporary memory. Any place where we rewind, it's literally just a question of backing up the pointer. And so in that case, we could say debug record block, I guess, rewind or truncate. And again, no real need to do anything fancy here. If we just pass that block, we should be good to go. So yeah, I think that's all we really need. With those three functions, we have told the debug system everything about what's happening inside of these memory arenas so that it can keep its own lists and keep its own track of what it may need to draw or record as far as arenas are concerned. And so the only other thing I think we really need is to go look at the arena part of things. And I think, what was that called? It's like debug arena? No. Okay. It's in here somewhere. I should probably just go to the code because I don't really remember what it's called. Yeah, I just have no idea what it's called. Casey doesn't remember what it's called. Oh, was that it right there? Yeah. So you can see here we've got this debug value and you pass these arenas, and I'm thinking that I don't really necessarily know that I want to do it that way. What you can see here is we've got this debug data block memory. In the old days, I think we kind of needed this because we were placing these like arenas in there as something we wanted to view. I think we just want to show all arenas that have been tracked in kind of like a scrolling list and do that, which we can do. And so what I think we want to do here more is just associate names with arenas. So in other words, what I would like to do is something like this, where we say, look, you're going to hear about a bunch of these arenas. I'm going to tell you how to display them in like a human-friendly way, right? Because it's just going to get these pointers, and it doesn't know, like, it doesn't know what those arenas would be called to a human. It just knows that they're, you know, something that's allocating memory, and it knows who's allocating the memory, but it doesn't know anything else, right? So I think what I'd like to do is something along these lines. We pass these pointers down, right? Like so. And we just say, look, I'm going to tell you what the names of these are. There's a game mode memory. There's an audio memory or audio playback, right? There's a frame temporary. Okay. There's a little bit of spelling for you. And then there's like an asset store. And so I think, like, you know, this is probably the best way to do this. Anytime something's allocated or freed, we just pass a pointer and say, here's the arena that was associated with. I don't know anything other than that. Just deal with it. And then later, we can announce in a central place, anytime there's a particular arena pointer, we want to attach a name to that pointer. We just can. And it will basically use that as like sort of a hash where it just says, look, I'm going to look up what the name of this pointer is and display it if I've got one. If I don't, I'm just going to say unnamed arena and let you figure it out by who's allocating it, right? Who's allocating in it. You know what I'm saying? So I think that's what we want. And I think that would make it a little bit nicer just so we can understand what we're looking at in there. So if we look at the debug system, I don't think this is actually going to be that hard to implement. It's just a bit of typing. I think the debug arena is there for our ability to store permanent things. And so really all I need to do is develop a little storage for the things I just said. So we can in here say, look, there's a debug arena and or debug memory. I don't know how we want to, I don't know what I want to call this. I'm going to call it debug arena for now. Inside the debug arena, I know that I want a name for this thing, right? And that's if I associate it like this. So I want to definitely have a name for the thing in the debug arena, and that's going to allow me to associate the pointer with it. I also need the like arena pointer because I want to store when I do like hash comparisons or something. I want to be able to kind of store that information for matching. And so if I've got the debug arena and I've got these things, I'm just going to create what amounts to a, for lack of a better term, a mirror of what I'm being told by the arena system here on the debug side. And so in here I've got like the file name and the line number that I'm actually, you know, working with in terms of the each allocation. I know that I want the size allocated and the size used so that we have those two pieces of information that we can print out. So we know like who allocated it, where, how much they asked for, and how much was used. And then each of those can just be chained, right? And sorry, maybe the offset from the block, right? And so in each allocation, we sort of have this information, and then what we want to do is inside the arena block, we just want to say, you know, first allocation, and here we want to know, okay, what's the like memory address, right? Like where was this thing? And similarly, I want to be able to say what the next block was. So that allows me to basically store all my allocations in the block to which they you know, were associated. There is no real need to name blocks for any particular reason, so I think it just looks like this, right? And this just lets us create a mirrored structure inside the debug system, so it's not ruining the runtime of our game, and we can compile it out trivially. And it's, you know, you might ask, and it's a totally legitimate question, why not just make the arena store these things right with the memory. And the reason for that is we want to be able to compile it out because it's unnecessary for runtime. So I want to be able to compile it out, and I don't want it to affect how the actual memory is being laid out because I want to see how that memory is actually going to be laid out when we actually run the game with it compiled out, right? So that's why this stuff is going to be a mirror rather than just placed inline, which would be easier, right? Or injected in, right? And so anyway, when we've got this backing structure, that will allow me to display it and update it as necessary as we get information from the running game in through the debug system. I think this is mostly all we would need. I don't really think we need anything else, do we? I mean, I think that's everything. Yeah. And again, I want to say, like, yeah, I wasn't really that pleased with how the debug system ended up working. I think someday I'd like to go back and clean it up. This is more how it should look. We should have just built purpose-built things for what we wanted, rather than trying to make everything be, you know, rather than trying to make everything go through something generic. That was just dumb. But, you know, I, like every other programmer, make plenty of mistakes, and that's merely one of them. But anyway, this way we can just record the stuff directly, and off we go. Now, we do have an issue, which is to say that when we do this stuff, we may want to be handling multiple... So this memory could be coming from lots of different places and different threads. We have to be thread aware because we use threads in Handmade Hero, but also because computers really don't get that much faster these days. Single-threaded, they tend to get faster by being parallelized out to multiple threads. And so we really don't want to create systems that will prevent us from using threading or that fall apart the instant we need to analyze something that's threaded. That's especially true of debug systems, and the reason for that is because debug systems are oftentimes most needed with multi-threaded code, because multi-threaded code is the hardest kind of code. There's way more happening at once and way more possible errors than single-threaded code. And so usually you want to try to avoid scenarios that would create difficult code, multi-threaded code sections that then cannot be analyzed with your debug tools, because then you're putting yourself at like a double disadvantage. The code is more complicated than the single-threaded code you were trying to debug, and you cannot use your debug tools to analyze it. And so you want to try as much as you can, I know it's difficult, to make sure that your debug systems handle multi-threading and don't require like locking and things that would intrude on the multi-threading and change the behavior of it when they attempt to be, you don't want to Heisenberg it out in that way. You want to be as transparent as you can be in that sense. It's never perfect. Anytime you're analyzing something, it will change, but you want to try and avoid anything major. And so what I want to do here is when we look at these calls that we have, and we go to the debug interface system, I'm going to add them in here so we can make them. What I want to be able to do here is say, all right, for like these things that I said we were going to start recording, I want them to go into the debug stream first, right? This is very important. Oops. I want them to go into the regular debug stream first, not directly into the debug system. And the reason for that is I don't want to lock anything. I want them to just go into the stream of events, and then I'll pull them out later from that stream and create stuff from them that way, because that will allow me to allow this to all run multi-threaded perfectly without having any locking or contention or anything like that happening. It's just people dumping into an array. Well, there's still some contention, but it's better, right? So these are the calls we actually need. It's not immediately clear to me whether this call needs to occur or not. One could argue that debug record block truncate is sufficient and we should just call it also does anyone know why record block truncate? We were supposed to, because it's got the used. Okay, I'm like, why didn't we pass the amount there? Because we don't need to. All right, so we've got the block, file name, line number, the size. So this is the allocated size. This is the used size. And this right here is the result. It's because we want offsets inside the block, I may make it easier on myself here and just pass that directly. I don't have a strong opinion. You could argue it's a little bit better to not do it that way. I don't know. But if you look here, you can see when we compute this result, we're already doing an offset into the block. So I may just say, look, we know what that is. We're all friends here. I'm going to trust this system. And I'm just going to go ahead and pass that down. So that way we don't have to do any pointer arithmetic there that could be slightly wrong or something weird happening. I don't know. And so we're just going to record what the actual offset in block is. And off we go. And so I think that should be mostly all I need at the moment. I'm relatively happy with that. So here's the stuff we actually have. I'm going to go ahead and put those in here as dummies. That's so that when we compile this out, these calls do nothing. And again, this is why I wanted to go with a mirroring-based system, like I said before. In both cases, I just want it to be as unobtrusive as possible. So in the case where you compile it out, it's not there at all. It just completely goes away. Even the file name and line number information goes away completely from the whole system. And I wanted that to be a sort of a requirement of the implementation. Okay, so now we've got these things. We need some way of recording these events. Thankfully, we have a fairly flexible system that allows us to do that. You can see it here. This is how we've been doing everything. We've got these record debug events. And so if I add these in here where I can just say, let's record these events, some of them will be pretty easy. Some of them will be harder. What we know is they'll probably look like this. Right? This is... Actually, I don't know why it's... Why is it passing unknown and then setting it to set HUD? Is that because record debug event would complain if you passed it something that it didn't understand? It's been a while since I've used this. Let me just see what's happening there. So here's record debug event. Here's the event type that's getting passed into there. This is it setting the event type here. I'll be honest, I don't see a lot of reason for that. So I feel like you could just pass that down, actually. The GUID init, I don't think we want anything there, really. The name init, we could use ourselves, probably. So I think that's all good. I'm going to go look at that event structure. And what you can see here is we've got this sort of union of information. Here's us storing that memory arena P information there. These events are already 1v4 long. That's quite large, actually. That's 4 values. So we should be able to stick a piece of memory information in here that should allow us to do whatever we need to do. So given this record debug event call, I also don't know for the GUID stuff, what are we doing for that? Just debug name for the GUID. So I don't actually know what we would want to do there. I don't know if we need those GUIDs for anything in particular. That's a tough one. You know, just looking at how we're doing that, you know, you can see here, like, we've got this sort of a GUID. I may just do that, because that seems like the most logical thing to me. So inside here, we do debug arena name. I may just do something like this, which is just like, you know, set arena name. And I'm going to put this in, oops, like that. Right? And so one of the things with set arena name is I think it's kind of doesn't need anything special because the name could just come in as the name parameter, and that's all good. Once we get to things here like block free and record allocation, we're going to need a little bit more information probably. So here we've got, you know, arena block free, and maybe I'll call this arena set name. So these all just start with arena. The name parameter here, again, we don't really have a name for it, so it's hard to pass anything there. So we'll just say nothing for now. What we need to be able to do here is pass some kind of block pointer, right? And so we know we've got a platform memory block, yeah. And I don't know what memory arena P is there. Is there a reason we needed that to be specific? I'm guessing it's because of the way we did the debug HUD thing. So I'm thinking that maybe that is not super necessary for debug type memory arena P. It's probably was just for auto detection. So I think we could probably do memory arena debug type. So actually that block needs two things. So I'm going to actually say maybe we could call this, maybe we could call this something slightly different. So maybe we should say here, all right, this debug type actually is like memory op or something, and this is just memory op, mem op, and this thing is like, you know what I'm saying to you? And I guess this should just be in keeping with the spirit. And so in here, what I want is I want the pointer to the arena that we're talking about. I want the platform memory block that we're talking about. The file name and line number could actually go up into the GUID. That's probably what we should do with that now that I think about it. So we'll make that work. There's a little bit of gyrations we should do for debug record allocation. We can make that be nice and clean, so we don't have to, we can parse those out after the fact. So I think all we need here is just the two pieces of actual allocation information. So there's allocated size, used size, and offset. So we need like allocated size, used size, and offset in block. But what you can see here is this is like gonna bloat it out a little bit too big. You look at something like a rectangle 3, that's 6 parameters. I don't really want to bloat it too much more than that. So if you look, you've got, this will probably be the biggest thing in here. If you look at, like, it's bigger than a rectangle 3, right? And so I kind of feel like these things should probably have been, you know, I mean, I guess we could compress them though. We could only output the size we actually need. I don't actually know if we're doing that at the moment. Probably not. Let me take a look. Yeah, we're not. It's just a giant array of these. So it's a little bit annoying in that sense, right? Where we've got the debug memory op coming into the stream here, and we're sort of just, it's a little bit too big, right? And so I feel like this is just too bloaty at that point, and I would like some way of making it less bad. I would assume that probably the easiest way to do that, right? If these were not, if we just didn't track allocations that were too large, so we just marked them as such, that would keep this down to a more manageable size, right? We did something like this. So this is 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 long. Looking at something like this, that's 6. So, it's still just too big. It's just too large, right? And if you did that, I suppose that would do it, right? But it kind of, you're missing the overhang part of this a little bit, so you don't really know how much you actually used here, which is a little annoying. But hey, we can sort of work with that for now. I do think we can solve all this by just having the having this. We could like record 2 events, right? You could just anytime you need to do something bigger, like we should do that for rectangles as well. Anytime you need more than one event, just record more than one event, right? Just like tick forwards and just record like a sequence. You know what I mean? So you could just say, hey, every time you see one of these, you need to see one of these after it, right? And you just specify the same GUID for both of them or something like this, right? We could do something like that. I'm not going to go down that road right now because I just don't want to deal with that complexity and we don't super need it. But it's worth noting that like there's better stuff we probably could do if we put our minds to it here. All right, so looking at this stuff here, so we've got the arena block and so on. In these debug types, I want to be able to set the type differently and have it, it probably shouldn't come through here. It should probably be something like this, right? And I don't think I want to make different ones for each of these. I think they can all be that, right? So I'm going to call it like, hey, there's arena set name, there's arena block free, there's arena block truncate, and there's arena allocate, right? I think that's everything. And so in here, when we're doing our record debug event and all this fun stuff, 1 second, fix that there. So in here, we want to say arena block truncate. And in here, we want to say arena block allocate. Oops, sorry, allocate. And I think because these don't take anything in particular, I'm just calling them what their event is. But in this case, I want this place here to take the GUID explicitly. So what I'm going to change is this is actually going to be the GUID, and that's going to get passed through, and we'll go from there. So in these, where we have like allocated size, use size, offset, and block, like I said, that stuff is unfortunately not really that useful to us at the moment because we can't quite store it exactly that way. So what I'm going to do here is I'm just going to say, all right, let's go ahead and record what we can out of it, and then we'll see if it ever causes us a problem a little later down the line. So if we look down in here, we've got this like value debug memory op kind of a thing. So in all of these, we're going to want to set certain parameters of these. And we have arena block, allocated size, and offsetted block to be recorded. So in here, we want to say, all right, here's the arena. Here's the block. Here's the allocated size. Here's the offset. Nah. And what we're going to do here is just literally do like these things truncated to U32s, right? And we're just going to hope for the best. And yeah, someday we'll maybe try to do better. All right. So, boy, that's hard to read. There we Tell you what. How about that? All right. So for the other parts of this, we're still going to basically do the same thing, but we don't have any other information to record, right? So we're literally just recording the arena and the block, and off we go. In this case, we don't even have a block. We're just doing the arena, but we still need to say what the arena pointer was. Otherwise, we would have no idea what it was when it went to actually set the name, which is this, right? So I think that all would work just fine, and yeah. I think that gives us everything that we needed. Okay. So debug record allocation is now wrong. These are apparently not known, so we'll just get rid of that. I have no idea what this is. Oh, that's for event data. We don't need that. What are you complaining about? Trailing return type is not allowed after... Wait, what? I guess I'm not sure what that is trying to say to me. Trailing return type is not allowed after a non-function declarator. So my guess is that that's just because we haven't adjusted this to take the GUID yet where we were using it. Don't quote me on that, but so if you take a look at how we're using file and line here, essentially what I want to say is this probably needs to look more like this, right? And so what we want to do with the file and line number there is when we create those, we want to create those as GUIDs, basically, right? And so where we kind of munge all the information together into one thing and sort of store it away, right? And so if you look at how we're doing that, like debug name with the function, for example, is probably the easiest way to do it. But we could also have some other name there where we could put in like which one of these people was responsible for it or something like that would be another way that we could have that happen. So I don't know which one exactly we want to do, but basically we're just going to do a debug name. And so that way it'll create the GUID this way, right? Where it like builds the name up out of these piece of information. And as far as I know, it looks like to me the name part is never used anymore anyway, right? You can see it's just ignored. Because I think we couldn't figure out how to correctly make it weld on in certain situations. So kind of unfortunate, but that's just how it works right now. So what I think I'm going to do is just use this debug name here and say, all right, everywhere that we were doing a file and line, I'm just going to do debug name, and I'm going to like put the name of the thing that caused it to happen, right? So like in this case, it's, you know, debug name push array. And that won't come through right now, but if we ever sort of like modified our debug system to work around that, we got rid of it because of some Linux nonsense. Clang was being stupid, and there was really no way to fix it, so we had to kind of get rid of it. But that's just, you know, that's how that goes. It's not really Clang's fault. I think it was GCC who actually set the precedent of having certain things not be correctly... you know, I want to say it even got adopted by the standards committee, you know, in their infinitesimal wisdom. Things not being created as string constants. It's a long story, but you can go back and look at the archives for why we had to nerf that bit. It works just fine on Microsoft's compiler, but it doesn't work correctly on sort of the Linux origin compilers. All right, so once we've got those in there, now we should be passing GUIDs properly. As soon as I actually change this. Okay. So I think that's correct now. Unfortunately, that had nothing to do with the error, but that is something we needed to fix regardless. All right, so let's see. I have no idea what this is complaining about. The event seems fine. Is it just the fact that this comment is annoying you? I doubt it. So what did I do wrong there? Allocated size equals allocated size, which is getting passed in, which should just be fine, right? I mean, I don't know why it wouldn't be. Since this is a macro, I should technically do this, but it doesn't matter because it's not being used that way. Do you not like this? What do you not like? That's a very cryptic error message. And it's only on those two. So is there some other thing? When we're actually calling debug record allocation, we're passing arena current block, we're passing the GUID. I should probably, to be safe, also do this. Nothing, you should never be doing anything that would cause this to be happening, but just principle of least surprise for the caller. I'll just, you know. These getting passed should just work. I really don't know what that error is about. And if I quickly just double check that I'm not insane. I mean, that just looks really straightforward, right? Oh. Except, wait. Why is that working at all? These should have been dots the entire time. How did it think these were correct? What's going on here? Something very strange is happening. Like, how did it actually allow... What's... Oh... There's one space after our... That was just a preprocessor error. Oh my god. There was just a space after that. God, I hate the macro preprocessor. They couldn't have fixed it. 30 years, they couldn't fix it. 40 years? I don't know. These are all supposed to be dots. Don't ask me why I wrote them as arrows. It's not a pointer. All right. So let's see here. Name is an undeclared identifier. That's probably true, because I don't remember anything about that. Yeah, don't ask me what that's doing there. So I'm not sure what we want to put for the name. In this case, what do people normally do? It looks like they just put the string of the thing that they were taking. In our case, I don't know that we really have anything like that. So I guess I will just say, like, you know, I don't know. I could pass the GUID twice, I suppose. Other than that, I'm not sure. We'll have to see what we end up doing with that. And then we'll go from there, I guess. So, let's see. Size is not a member. Oh, right. This won't work. So. Let's just make that work that way. And sure. Free is not a member, again with the same problem. Oops. Just name conflicts. Let's just do this and leave it like that. Debug block truncate. There we go. Who is having a problem? Debug block truncate. And that's just a case of still passing this down for no reason. And we've got a unexpected. Yes, that is true. This looks like I accidentally deleted the closing paren. All right. So just a lot of fussing there. Unresolved external symbol, global symbol, debug. Oh, so because these events are getting recorded now, it looks like our test PNG doesn't have any way to record that sort of information. So I think what we want to do there is just make sure that we turn this stuff off, right, for the memory subsystem. So I would say that's probably just something that when we're doing test PNG itself, we probably want to do like that for the test PNG, just so that's not actually happening. I could probably do this actually. And we should probably do that for, yeah, for everybody. We could add the debug system to them, but it's just not worth it, right? There's no point in having that. Okay, so it looks like this is actually not, this is itself is a pointer already. And I guess that makes sense with how it's actually being used. So I guess I'll just go ahead and pass it directly. Other than that, I think we're good, right? What else we got? Oh, it's not supposed to be a colon. All right, so I think we're good. The only thing now is this doesn't want to be done the way it's being done here at all. We kind of want now our own way of displaying these things, and we probably want to display them sort of the way that we're displaying like this other stuff. For example, the thread interval graph, top clocks list, this stuff, right? I think what we want to do is this stuff should probably be what's displayed. Like we want the same thing. So we want to kind of get rid of this, since it's never supposed to happen now, and we just want arena occupancy itself to be the thing that's there. This will be rewritten, so I think we're fine to just do that. And then I think we can go from there. I think that's what we need. Yeah. So I'm assuming, and I don't know, but I think we've laid the groundwork now. I'm assuming if we ran it, we should now get an assertion that we don't handle the debug stream that comes in during collation. Because now, in the code where we are going to process, where we're like collating all of our events, which we haven't touched in years, right? But here, collate debug records. This stuff where we've got debug begin block, end block, data block, close block, set HUD, blah blah blah, right? In here, I guess we wouldn't actually have it. It would just flow through here and not do what we want, which is record it as specific memory events. So what I want to do now is I want to take those memory events and make sure they get handled by specific code designed to do the right thing. To record what's happening with our memory. And in this case, it should be pretty straightforward because these things have exactly, we designed them purposefully to have exactly what we need to create a backing store of exactly the information about who allocated what and when. So inside here, those will now flow through and just get ignored, but we can soon break them out into something that actually records the correct information. And so if I now run the game, I just want to make sure that everything's still flowing properly and that nothing bad happens. Looking at our debug, you can kind of see here we've got everything but the memory is now available. This is all working properly, right? And so I think we're pretty good to go here. So now what we want to do is from the debug events themselves, we want to translate these debug events that are in the debug buffer into calls that will actually create the mirror structure that I typed in just a few moments ago. So each of these calls should essentially create an operation to this stuff right here, right? We want to now start creating these three things, right? So the first one's pretty easy, right? What we would do here is we would say something like get arena by pointer, you know what I mean? And we would pass here, well, all of these are going to use effectively some kind of a cast down of the actual event. So in here where we actually get the event in question, which I assume is this right here, we're going to want to do something where we say like, hey, debug memory op, and maybe it should have been called memory event, but who knows. I'm just going to say, look, give me just that part of this thing, right? So we're just getting out the memop part of this, and then we're going to use that to figure out what's going on. So what I want to do here is I want to do like a debug get arena by pointer. I want to pass the arena that we recorded. That should give me back one of these, right? And then I can go ahead and set its name. So that allows me to just record what arenas are called for pre-printing, basically. And so now what I need to do is I need to manage the actual allocation stack in there so we can kind of see what's actually available. Now, in the future, what we probably want to do as we sort of get a little fancier here is, and I'm going to put these to-dos in there. I should probably, you know what, I'll save these to-dos for later. I'll explain them a little bit later because I'll put them in the actual functions. But anyway, where we have, and maybe I should make this do that too. Yeah, let's do that. So up here we'll just have our calls and we'll just thunk out to them immediately, right? So this will be arena, right? Arena set name. This will be arena block free. This will be arena truncate, and this will be allocate. So each of these, I think what we want to do is just pass the debug event down, and we'll take it from there. And so I'm going to put this up in here. And that way, you know, these things are just called out to. And I do that because I think I might want to I just want to kind of be able to see them as the four ops and make them do what I want them to do. All right, so here's allocate, here's block truncate, and here's block free. These will want the op, but they'll also want the event. That's why I passed the event itself. That's just necessary because the event has information like the name and stuff like that in it. So I'm going to go ahead and grab this in each case. And then I'm going to go ahead and do the actual work. All right. So in here, what we're going to go ahead and do is say that, all right, when we do an arena set name, right, we're going to get the arena. We're going to set the name to whatever the name says it is. In the rest of these, right, we're going to need the same thing. Oops. So this is kind of always going to happen. This is probably just, the first two things of each of these. Is that. But then each of them is going to do something a little bit different. So when we do arena block free in this case, now what we need to do is we need to scan the list of blocks in the arena, and we need to get rid of the one that it asks us to. Now at the moment, we happen to know that block frees will always go in reverse order. So we may be able to just do an assertion and just take the easy route here and actually write something even dumber than that. Which is to say that when we look at the block pointer, we may be able to verify what it actually, that block pointer is the top one. So I might just do an assert arena first block memory address equals whatever this block address was. Do we have hold please. I want to look at what our conversion is. I know we've got some. So it looks like we don't have a way of casting between these, so I'm going to actually do this. Although actually that should probably not be necessary. That should just work. All right, so I'm going to do here, I'm going to say I want a UMM from this pointer, which is the block in question. And I'm just going to assert that these are the same. And then I'm going to go ahead and remove the first one. So I have the debug memory block or something like that. Debug arena block. Why am I calling it an arena block? I don't know. Who knows? We don't even call these arenas. Well, we sort of do. We call them memory arenas, I guess. I don't know. Who cares? Anyway, I'm going to go ahead and get this free block out of here. In fact, I could do this, which is just to say that let's assert that this just all works. And then I'm going to say, all right, the arena first block is going to be whatever the next block was. And then we're just going to take this block and all of its allocations, and we're going to move them to the free store. So we're going to take and have, in our main system here, we're going to need, well, we're going to need a couple things, right? We're going to need a hash here for our debug arenas, because we need to be able to look them up by pointer. Not sure where that should go, but maybe it just goes here. So in our arenas, we've got, lookup. That's too many for this. It doesn't even matter. I don't even know that we need a hash. We could just linearly search. There's only going to be like 10 of them or something, right? I mean, how many arenas even are there? But, we've got arenas that we're looking up here, and the arenas are never going to get freed. So we always remember every arena that we've seen, I think. To be fair, I guess we kind of need to get rid of them, though. So I guess we... Yeah, so maybe I don't want to hash them. Maybe I just want this. I think that might be fine. And then we want blocks and allocations. So that's, I think, all we really need there. And so what I'm going to do is just put it onto that list when we free the block. And what I need to do here is when we actually free the last block, we need to free the arena as well. Does that make sense? So we can do debug get arena by pointer because we do want that. But we are going to just now linearly search that list instead because there aren't that many arenas, and I guess I just think it's a waste of time to do something more complicated for fetching them. Yeah. So for things like block truncate just gets rid of allocations that are after it. So what we're basically going to be doing is moving things off of the list and into the free list for a particular block. And then a debug arena allocate will just be putting things onto those blocks, right? And if there's a new block, we actually use the new block. Okay, so let's just implement all of those, and then I think we're good to go. And then we can go work on rendering them in some way that we can inspect. So what we're going to do here is say, all right, when we free a block entirely, what we do is we take the first block and we assert that that's got to be the one we're freeing because we don't allow freeing out from inside arenas at the moment. And so we're going to go ahead and advance it to the next one, and then we're going to insert this block onto our linked list. So basically, the debug states first free block, right? The free block itself is going to point to that thing, and then it's going to point to the free block. So we're just pushing that on, right? So that's basically going to take it off of here, right? It's going to remove it. So in fact, I'll just note it for you. And we're adding it back. So the only other thing we need to do here is have a while loop that gets rid of all of the stuff that's actually on all of the allocations that are actually on here. Those need to go to the free list, right? Now there's two ways we could do it. One is we can do a while loop here, and the other is we could actually keep a tail pointer and then just move the whole thing in one go. I like tail pointers, call me crazy, so I think I may just do it that way. Like so. And so what we're going to do here is just say, look, since we know there's a tail pointer, we're good to go. If the arena, if the free block, if that free block, whatever the free block is, happens to have any allocations on it, then I'm going to go ahead and move all of those allocations over to the free list. So to do that, it's pretty straightforward. We just say that the free block last allocation, whatever that one was, its next pointer is going to point to whatever the first free allocation was, right? So we're just saying chain it so we have one big long list of free blocks, and then the debug state first free allocation becomes whatever our first allocation was. So now we have a big long list just chained up there. So that just allows us to move them all at the same time, right? So that's pretty straightforward. And again, this can just be done in constant time if we do track a tail pointer. And since we're already in that cache line, tracking the tail pointer should be effectively free. So I think it's a better trade-off than spinning through all that memory for no reason. So in here, we've got the set name function should just work. We've got the debug block free. That looks like everything that needs to happen there. We've got the block truncate. Block truncate just needs to move things to the free list sequentially. And so I'm going to do the same thing. In fact, I may just do this. I think I'm just going to do that. And that way in here, we can call this function, debug move to free list, with both of them. So the first free allocation and the last free allocation. Sorry. I meant first allocation and last allocation. We can move all those to the free list this way. And reuse that. Right? So I think all that's good. We could also assert that the last pointer is valid, because if you have a first pointer, you should have both or neither, right? So we could just make sure that that's true. So that allows us to move all these to the free list. What we would do for truncate is basically the same thing. We would just say, look, we're going to go through here and we're going to look for all of the allocations that would be precluded by this retraction in the size of the block. So for this arena's first, its top block, we want to, I guess we want to do the exact same thing we're doing here. We want to say, take that top block, assume that it's the correct block, because we should only be truncating the final block of the arena, the most recently allocated one at any given time. Then what we want to do is just step through that block and see if we ever... we want to see how many of its allocations would be invalidated by the rewind that has happened because of the truncation. So what we want to do is say, let's start with in fact, we could do this. There we go. So what we want to do here is say, all right, let's start with the first allocation. Let's push this pointer all the way. In fact, let's call it first valid. That makes more sense. Okay. So let's take first valid, and let's push that all the way to the first allocation in this block that will still remain after the rewind. So what we want to do is say, okay, I guess just while first valid, if the first valid thing is correct, we break. Otherwise, we do first valid equals first valid next, right? So inside each of these memory blocks, we know that we have an offset from the block boundary, and what we want to do is see, did we rewind past that allocation, right? And so if the offset from the block is now higher than the size that the block actually is, which, you know what, we didn't record. And we need to. So that's something we need to fix. So in here where we have the interface, we need to fix that. Yeah. So in here where we do the offset in block, we need to record that. So that needs to actually be specified here. So when we do that call, which is here, so when we do a block free or the arena name, those are both fine because they're storing information we can use to reconstruct what happened. This one, well, and so is the same with the allocation. This one does not. We need to, in addition here, record one more piece of information, which is off of the block pointer. We need to know what the used size is now, right? So when we do the record truncate there, we have to make sure that we're calling it at the appropriate time. So that would be right here. Yeah. So you can see me, doing it here. This is where that needs to happen, right? And so I think what we want to say is, keep this in the like allocated size or whatever it is, and do that, right? So I think that's where we're at. Yeah. Okay. Good, good. Okay, so let's see here. First free block, we must be using that for something else. What is it saying? Yeah, it's this other kind of block here. So I guess we need first free arena block. Okay. So let's see where we are at. It looks like for some reason memop is not a member, right. I think we called it the actual name it is, which is memory op, right? Debug memory op, yeah. So that's actually supposed to be that. I just forgot. We named it consistent with the other things in that list. Even though we don't really need it to be, we did anyway. Okay. There we go. So going back to where we were at, I want to finish up what we were doing here. So when we actually go to use these things, like I said, this will move it to the free list. This has to be arena block, like I said, because we already have something called block there. But let's get back to truncation. So in truncation, we start at the first link, and we go, every time we're going to do this, we want to see whether the offset from the block is higher than the, or equal to, I guess, the allocated size value, right? So if the offset in the block is higher than what the allocated size is, then we know that this thing is now no longer valid. And so I guess the way we would do it is this way. We stop at that point, right? So we want to advance this to the place that's the first valid thing that will remain. If the first valid it just doesn't exist anymore, meaning if we rewound all the way back, then we're moving the whole thing. So that's effectively going to do this, right? If that makes sense. Otherwise, we want to move a subset. We want to move all the way to first valid and not any further, right? So in order to do that, the problem is this is not a one past last kind of a scenario. We actually have to pass the last one we're actually moving. What that means is we really sort of need the one prior to the one we stopped on. Something like this. And so each time through here, we sort of need to do that. And that's the one we actually wanted to send down. Like so. So I think in this case, also the interesting thing about that is that means we don't have to do this anymore. I think you can literally just do the if. If we've, if we haven't advanced, meaning if we didn't go anywhere, then we don't want to free anything. That really probably should never happen, but just in case it does. And then what we want to do is free everything else up to that point, right? So I think that's correct. We'll see. We should still get this call, so I don't think we need to free the block in the case where everything got freed. I think we're okay. But what we do want to do in either case is if we update this, we need to change what the pointers actually now are. So the last allocation would still be valid sometimes, but the first allocation will always need to change. In the case of last allocation, what we want to do there, I guess, is just see whether or not we freed everything. So we're going to have to do a little bit of an if there. But for the first allocation, we know that first valid is the correct thing there, right? And for the last allocation, we just need to say if we are freeing the entire list. Another way to say this that might be clearer would be if the free block last allocation equals the last free, then that means we freed everything, and so it's gone. Right? So that allows us to get rid of any allocations that have now been rewound. When we do our allocate, this is actually the easiest possible case. In this one, we just need to create a block, if there wasn't one, and place the memory in it. Right? So in this case, what we want to do is say, all right, this is really the only place that we're allocating blocks or allocations. But we need to do arena block, debug arena allocation. And so in this case, what we need to do is say, look at the top block of the arena. If the top block of the arena happens to have the particular characteristic we want, then we use it. Otherwise, we create a new one, right? So I believe this should just look like this. Like that. And we have to check whether the block is valid here, because the first time you allocate something in Arena, there will be no block at all. And so we do need to say, look, let's look at that first block. If we assume that it's, if it's invalid or it doesn't match what we're trying to do, we make a new one, right? And we could scan, but we could assert, if we want to later, that there isn't already a block somewhere else with that address, but that's sort of a separate check. I don't know that we really need it. So anyway, we're going to take the first block. If we didn't get one, then we need to allocate one. So then we're going to just say, all right, push struct debug arena block. And that's going to come from the debug state. Debug arena. Is that what that thing's called? Yeah. So we're going to do that, but we can get it from the free list as well. And so assuming that, assuming that we could, but assuming that we can't, we just make a new one. So we really don't ever say, oh, we got to stop. We take one for the free list if we can, otherwise we make a new one. In the debug block itself, we don't really have to do anything other than add it to the list of blocks for this arena, and then track what the allocation actually is. We know the first allocation is 0. We know the last allocation is 0 when we first create a block. We know the memory address is just whatever the memory address is. We already found it up here when we were looking to see which one we were doing. So that should be a simple matter. And so the only other thing we need to do is just create that next pointer. The next pointer should be whatever would chain it onto the arena itself. And so that's the entirety of constructing that stable state in memory. Finally, we do the same thing for the allocations themselves. We know that there can't be an existing allocation, so we always need a new one. So what we're doing is we're saying, like, first free allocation is what we want. If there wasn't one, we need to do some work, right? So if there was one, then the next pointer, right, is going to be used to sort of maintain the free list. But otherwise, we need to create a new one from whole cloth. So that's maintained now, and finally we just fill out the information that goes in there for any given allocation, which is this. I guess file name and line number are probably the wrong things to be tracking now. Instead, what we do is we track these GUID things, right? So we just want to put the GUID in there. And that comes down just as the event. Like, that's all I think that actually is. And so we just need to record this other information. We've got the offset from the block. We've got the size allocated. And we've got the size used. Unfortunately, we can't really fill these out properly yet because we don't send them all down. And so for now, they just have to be sort of front bid, you know. So, you know, one of the things that we could do too is we maybe don't really need the size used anyway. In fact, I think I'm going to delete that because what I realize is that'll just show up. When you look, you'll see the gaps. So I guess we don't really need that. Like when they get drawn, you'll just see the gaps in between them. And you're like, well, that's the memory we're wasting. There it is, right? So that actually seems fine. We may also want inside the block to store the total size. So that we just know how big it is. And so I think I may want to do this. That would come from the debug memory op, in this case, has that size allocated field. And I think that's where I would want it. So if you look up here, we can just place that into, you know, these two things are capable of recording that for us, actually. So I think if we just went down to the place where we actually do the... Oh, wait, no, I take it back. We don't know that because we don't ever actually record a block allocation as its own step. Maybe we should. I think maybe we should. Because since we know when blocks are allocated, we should probably record it. Because it would literally just look like this. Used is not what we want here. So the platform memory block, in this case, oops. We actually want the total size here. The, The memory arena itself, why? That's not supposed to be used. That's supposed to be total used. Right? So how did that fly? Shouldn't we be getting an error on that? I'm just going to assume that we would have been. So that should be total used, and this should be total size, right? So I'm just going to say that that would have been an error, and without actually looking, because we've got too much other stuff to bother with right now. But total used is not a member of platform memory block. Isn't it, though? Oh, that's stats. Okay, never mind. Sorry. I take it all back. It is used in size. Sorry, everybody. Sorry about that. Okay. Minor diversion. All right, so moving along here. So if I want to do that, then what that means is when I do my collation of debug events in here, I just have one more to worry about, right? I just want to say arena block allocate, and I call it here. That's really all that has to happen. And then when I move in here, because I guess I have that now, block allocation there, I need this one to make sure that it goes away when necessary. All I need to do is just call this block allocation anytime I actually produce one of these blocks. And I believe that the only time that that happens is inside here. So when this occurs, right, you can see me getting the new block right here. I should be able to just go, all right, here's the arena, here's the current block, and we're done, right? Because there's nowhere else that actually ever allocates any blocks, as far as I know. It's completely isolated, which is exactly what we want and is good. So when I actually do that here and we have the allocate, all I'm going to do is pull out the code that I was just doing implicitly there. So this part right here where we're sort of allocating that block at the outset, that right here, we're going to just change this back to one of those assertions like it was before. So this stuff will come up here and we will deal with that, right? But we're going to change to just assuming the top block is accurate. So in here, anytime you push an allocation, we're like, it better be on the current block. Otherwise, something got out of sync and we need to fix the code. The debug code is obviously like, you know, misbehaving. So when you tell me to allocate a block, then what I can do is avoid this sort of nonsense altogether and just say, okay, we know we need a new block, so we're not sort of doing this kind of test anymore. What we're doing instead is going directly, right? We're going to say we know we need to allocate a new block off of this arena. I should probably put these in there, though. So we know we're going to get a new one. Assuming we did, we unchain it. If we didn't, we create a new one. Then we need to fill out all of the information on there. This has to go right there. But otherwise, we just fill everything out. It doesn't have any allocations to start with. This is the address it actually has. Here's how much space it got reserved for the block, and then we chain it together. When we go to the arena allocate now, we just say that it better be off of the main block. Then we do the same thing, get ourselves something to use to record it, and then we need to actually put it on to the block in question where it's supposed to go. And so to remember to fill out all the rest of these, we just say, okay, we've got the GUID, we've got the offset block with the size allocated. The next pointer is always going to be 0 because we're chaining these onto a linked list in the order in which they're actually allocated. Although we still want them in reverse order, so no, actually we're not. That's not true. So the next pointer is, because we want these to push on like a stack. So, because we want the most recent allocation to be first. So what we're going to say is, all right, the next one is for whatever block we ended up using, its first allocation is going to be the next one here. And then the block first allocation is going to be the one we're on, right? And now what we have to do, because we decided we wanted to keep a next pointer, is the next pointer has to get updated. I'm sorry, a last pointer has to be updated as well. And the way that we update that is the last allocation always stays the same unless it's 0, right? Because the first time we allocate something in the list, everything else comes on before that thing, right? And so that last pointer just stays pointing to the element it's pointing to no matter how much stuff we put on it. And so the only thing we want to do here is say, look, if there was no last pointer at all, then we are also the last pointer, right? But otherwise, we never touch it. So that first allocation is the only thing we're updating each time. We're pushing that backwards. The next pointer is, sort of going to the allocation that happened prior in time, if that makes sense. Like it's the previous allocation that happened or something. All right, so we need a get arena by pointer for when we're collating. I'm going to leave this out for now, like so. And I just want to take care of all of our compile errors before we get to that. So what is the problem here? I don't know what the problem is there. We'll look at that in a second. These all just kind of need, though, to pass the debug state. Let me go ahead and make sure that's happening. And then we'll address it in a second. Okay. This is actually event name, so that's why that was wrong. The opt itself, it doesn't have the name. It's in the outer debug structure. So let's see here. This is just block memory address, not free block. In fact, I don't know why free block was ever used there. We're not actually freeing the block. Block remains untouched, actually. This is off of the op, not the event. In this case, this is the first block, not the first free block. Well, actually, no, it is, but it's off of the debug state. There we go. Same here. What else we got? So the debug arena block, first free arena block, we made that mistake before. First free arena block. And does this need an address of... Size allocated seems like that should just work. What's the complaint? For the... Those both have a size allocated. Oops. But does this? Allocated size. All right. Good consistent naming there, Casey. Yeah. Let's see what we got here. So again, that's off the debug state, not the arena. This needs to allocate here. And this is, don't tell me, allocated size. So in this case, the allocate, the offset from block, let me go ahead and jump directly to that. So in the debug memory op, we called that offset in block. Yeah, this is not a good naming day. Wow. Two is the exact same thing, and I didn't manage to call it the same thing. Always good. So we've got arena block allocate here. Oops. We've got arena block allocate here. We need to add that in. I guess I'll do it like that. And when we actually go into the debug interface, we need to make sure we're passing that properly. So we've got the block allocation. I'm going to move that down so the allocations both parts are together. This is going to be a block allocate. And then I think we're pretty close. So in here we've got, in here we've got debug arena, results. I guess I could just call it, I'm gonna call it result. And I'm gonna return the result. What I wanna do here is say, find it for me. By looping through everything. In this case, like I said, I just decided it's not worth it to try to accelerate these. It's probably just going to spend more time than it actually saves, because there's only going to be like 20 of these things, right? And so linear search, you know, you really don't want to start putting in kinds of weird acceleration structures for things when there's not enough of them to act. Like the amount of time you spend handling those acceleration structures just ends up being slower than if you just checked to begin with. So in this debug arena, I'm just going to test to see if we've found the one that we're actually talking about here, and go from there. This doesn't need to be a void. I'm not sure why I did that. It could just be an actual pointer to the arena. And I should note, so I just want to make sure people know you shouldn't be doing anything with it. It's just there to let you know. So maybe that, you know, maybe you would argue that that should be that way, just so people don't get the wrong idea. So all I want to do here is say, look, is the arena pointer the same as the one that I'm asked to find? If it is, then I'm going to say that that's done. And off you go. If we couldn't find it, then I need to allocate a new one. So at that point, I'm just going to say, let's go ahead and create a new one. Let's fill it out. Although, you know, I could name it with the first person who used it. I don't know that I want to do that, though. I don't want to do that. And so then I think that's it. So we're done now. And now we have to actually get all this working. The debug state first arena here just needs to be updated to make sure this is all chained together. But other than that, I think we're fine. What else we got? Okay. So now we just have to debug this, but it should now be recording everything that happens in there. And once we've debugged it, we should be good to go, right? I would hope. Let me switch to debug mode so it makes it easier on us while we're debugging. We don't have to worry about any kinds of crazy nonsense that the optimizer may have done. We can see our errors better. So off we go. We're running now. We're collating a frame, and it looks like we're getting a arena allocate call on something that didn't have its block allocation at the top, right? And so we got to figure out why, you know, what happened. And let's start by looking at the arena itself. So looking at the arena, you can see that it just didn't register a block allocate call. That's the entirety of the reason. And so that suggests to me that there's something wrong with the way that we're actually calling block allocate. Because we shouldn't have had that happen. So when this occurs up here, it should have pushed that on there. Specifically, this piece of code right here should have been called. I'm going to go ahead and set a breakpoint there and see. I just want to see what happens right before that event. So you can see that this is working properly for a little while, but then it fails at some specific point, right? So it's not that we never created the correct setup for an arena. It's that at some point we did an incorrect. Somehow this got mucked with, right? So let's take a quick look and see if that particular arena was ever implicated or not. So I'm going to go ahead and do this. So here's one arena that we called the block allocate on. I wish I could cut and paste this value. And then when we come down here, you can see we're using the same arena. Come back up here, same arena. Different arena now. Although, you know what? Actually, am I being stupid? Maybe Remedy is better than Visual Studio in this way, and I should just use it. Let's find out. We come in here and we get this arena. So I lock that value. No, it did not work. Although this one didn't update. I don't understand. That was weird. Did it work or didn't it? Let me pay close attention. We come in here, we've got 1B143F1C1B0, right? I lock it. I run. And that one updated, but this one didn't. Oh, that is, okay. So that probably locks. That locks it to look at that stack location, probably. Is there any way in Remedy to lock the current pointer? Like just this thing? I want to know. I guess not. George ain't out there today, is he? Probably not. I think he's on vacation. Actually, I think he said he was on vacation. So I feel like this would be a really good feature, potentially, which is like, and maybe we can send it to George, send the recording to George, if someone can mark this for me. What I want to be able to do is come through here, and I want to say, like, okay, I hit this thing, and arena was this. Let me, like, and in fact, the best possible version would be, it looks like this, and I, like, right-click or something, and there's a menu which is, like, remember this, like, keep showing this. And it would add, effectively, this, right? It would just add, like... It would add that automatically so that when I run, I still have this one always, right? And when every time it changes, I just right click and save it again. So I've got them all. Do you know what I'm saying? Like something that makes that really quick and painless so you can just do it anytime you want. Or maybe you can even set a thing that's like save every time there's a new one of these. You know what I mean? Because that would be so handy, right? Oops, I screwed up. I think I was supposed to type F8 there. I did it wrong. I copied this one. All right, so... So if we look at these two properly have first blocks as we would expect. I'm going to set a breakpoint in the block clear code as well. That one should get a block. It does. Who are we on now? We're on 360. That's fine. C8. So we're just creating plenty of different arenas here. And we're allocating off the one we just did. And so it's actually that one we never allocated. So we never saw a block allocate call for that one, did we? Let's verify that that's the case. So we get 4 that we do, and the 5th one screws up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 5 that were correct, and 6 fails. Try it one more time. Okay, so B0 twice, F8, 6-0 twice, C8, and then this 3-0 guy we just never saw. So is there some way that an arena gets a block allocated that wouldn't go through the path that I'm talking about? Right? So in order to do that, you would need to have gotten here. Well, okay, so here's a question. What if you allocated 0? Maybe I just need to special case that. Did it allocate 0? So here's the event. No, it actually allocated something, and it thinks it allocated something at 32 offset, right? Who's the person involved here? It's Handmade Win32 at 1298. I wonder if this is because this is a Win32 layer problem. Who's doing that? 1298. So it's the file group memory in particular. When does that... Well, I guess it would be fine, right? I mean, it's just created as a zeroed out thing. And in theory, when it first enters that push struct, it should just allocate a block. Right? So I'm not sure why we would be seeing the allocation prior. I'm just not sure why we would be seeing the allocation prior to when it was actually... Or why we wouldn't see the block allocation prior to when the allocation is used. The fact that it's the Win32 makes me worried that this is because these are two different modules recording events. And so are they doing, is there some kind of out of order problem that happens there? I don't see why there would be, though. So I don't know. These should happen in the same order. So what I'm going to do is I'm going to take a look at push size, and I'm going to see stack-wise, when does this stuff happen? So here's a push size that's happening on probably the game, right? Oh, no, it's here. So it's doing a bootstrap. It's actually the very first thing that it does, right, for the getting the file types. I suppose another way to do that would just be to go like this. Access violation. What? Did I miss something? How did that cause an access violation? Does that, again, I'm just concerned that has something to do with something we don't really remember about how those two are partitioned. All right, let's take a look. So there's the arena. Yeah, so I mean, that's just clearly somehow it skipped right over this. It just never called it, right? So why did that happen? Why didn't it call? Let's try and step through. Let's just make sure that happens again. So first time through, we record a block allocation on arena. It's like E8, right? Then we allocate on E8. Then we switch to 40, and we never saw 40 never hit here, right? So how is that possible? Like, how is this able to, like, Win32 file group memory now is like a, oh no. The plot thickens, doesn't it? Oh, this is saucy indeed. So do you guys see what happened there? The problem is that the memory arena is actually just a thing you can move around. It doesn't, all that matters is that this chain is correct. And so when you do a bootstrap, you use a different arena. It's temporary for the initial allocation, and then it relocates itself to inside the place it allocated. So while we can still track the memory just fine, we wouldn't have any way of naming the arenas the way that we wanted to. Because of the ability you have to do that sort of squirrely little maneuver. really don't know what else we could do here other than when you first make a memory arena, we mark it. I think that's the only thing we'll really be able to do. I mean, I really just can't think of any other way to do it. We would need to put something in here effectively, right? Where inside the memory arena, we add a debug tag that only exists at debug time, right? And we could work around this specific problem because Bootstrap Arena happens to know that you moved the arena, we could simply add a debug call that says the arena moved. But the problem is, I don't know that, like, anyone could still do that on their own. Like, anyone can still do this on their own, this copy. And so we could just enforce it by discipline and say, don't do that, or make this call when you do, right? And I guess that's fine. Because that's the only other way I can think to do it. In other words, you would have to do this. You know what I'm saying to you? So effectively, you would not really be allowed to copy an arena manually. You'd have to copy it yourself, which I hate that kind of crap. So I don't love this, but maybe it's the best compromise. Because the only other thing I can think of is you have to mark them. That's not where that goes. Right? Like, I just don't know. I don't know how I would track it. And so if we want to be able to name them, that's the way we would have to do it. Let me think. Is that really true? Did I just say something stupid? No. I am being stupid. I think I can actually pull this off without that. And I'm going to try. I'm going to argue that if we just let this be the way that it was before, without a move arena call, there is a way we can do it, and we just have to change our thinking a little bit. Right? So, inside the debug system, we're looking up arenas by pointer, right? But what we know is that arenas are just strings of blocks. So if instead we just did this, oops. And said arenas are just a named string of blocks. In theory, I think that would always work. Meaning, when we go to get an arena, if we just knew what the top block pointer was at the time, that should be sufficient for us to maintain the chain. The problem, of course, is that the blocks themselves, it requires us to record what those blocks actually are, which in some cases is trivial. In this case, it just works. In this case, it just works. In this case, it just works. And in this case, it just works. The only one that's complicated is this one. And so when we allocate a block, we just have to pass the old block that we were using. You with me on this? This is some seriously nutso stuff. So if we were to say that or that, I think it works. And then you always look it up by this block. So when we do debug get arena by lookup block, we're just always going to do this here. And I'm going to argue that that will actually work, because as long as we always pass which one it would have needed for that, I think you can just maintain chains without ever actually thinking about an arena at all. And then you just need to know which chain you're talking about, which is always correctly identifiable by whatever the top block was at the time, right? Because that's just how the arena is working itself. So I think if we do that, oops, then this whole thing just kind of works. In here, we just say whatever the first block is, it should look at that, like that, right? And I think that's all there is to it. Oh, but it's not first block. It's that. Right? I think that's correct. And so then what would happen is whenever the final block got removed, at that point, you would have to record that the arena went away entirely. Right? I think that's the only thing that becomes sort of complicated. So when we're doing that lookup, you have to go back and say, yeah, you have to actually be able to clean those out, which I think we would have had to do anyway now that I think about it. So that's actually no different than before. So I think we just have to track that fact that whenever you clear an arena down to 0, we have to remove it from the list. So in the case where you do a block free on the last block, right? This case right here, you have to do a thing that basically says if the arena first block is nothing, then this has to be scheduled for removal. And so I think that's okay, and we can schedule when we want those arenas to be cleaned up so that we don't have to remove ones until later if we want to. For at the moment, I guess I would say we probably can just remove them now. But in the future, if we want them to persist so we can inspect them, we may want to do something like just marking blocks as being free, you know, and cleaning these out as sort of a separate pass so we can watch what happened. For now, I guess I'll say, look, we just remove this arena, right? And I think that's fine. All right, so this is pretty tricky, right? It's pretty nuts when you think about it, but I think that all just works, and the only thing that you need to do is normally, yeah, you would just pass the same block there, but in the case of one of them, you have to do a little bit extra. So in all of these cases where you're setting this thing, it's actually arena lookup block now, and what's going to happen is it's just whatever current block is, right? Has to get set. So in here, where we do like arena set name or any of this stuff, really, arena set name, I think, could technically occur in a case where there wasn't a top block at all. And so I feel like that one makes it a little bit harder to work with. So in this case, we would, I think, have to say that if we didn't have a top block, we couldn't name this arena yet. So it probably looks something like, this. You know what I'm saying? But otherwise, yeah, I think it's always just this. Oops. And so looking at these in a little more detail, I think we can then go ahead and be a little bit more specific about how these things are working. If we come in here, we can sort of see that like the record, this is just passing the arena current block anyway. So I think we could just say, all right, on a record allocation, we're really just doing, we're just passing the same block twice, right? And so I wonder if maybe it makes more sense to say, in that case, we just pass this. So it's just BL, BL, right? For truncation, let me grab that. For truncation, it's the same thing. So I think, again, that's not changing which block is up there. And neither is this. So I think these are all just this. Right? And you don't need that arena anymore. And you can sort of see where I'm going with this, hopefully. This is, again, pretty complicated, but I think it works. So we can do the lookup block here. From getting the AR, get these two, just use the BL, and so all that's good. The only one we have to do here, this is the weird one. It's this requires a previous block. So when we actually go to record a block allocation, we need to know which one it was when we actually did that block allocation. So when we do debug record block allocation, we need to know what the one was that was before us. In order to do that, I think what we want to do there is we need, and in fact, now that I think about it, I guess we kind of always know which one that is, because you can see we have the arena prev here. So actually, if we just do this, we can actually just do this. So I think that's all good. And furthermore, because this actually shakes out to be much more interesting, it means that because we've got an extra field here, we can actually get a little bit more ridiculous if we want to. So if we go to debug memory op now and we look at what's actually happening, it means that this could actually be more explicit. So if we have block allocate, right? We've got something like this, and then we've got the allocated size. In this case, all of these don't need another one. So that means we can get what we wanted, which is these to be fully, these can have the complete memory size, so they don't have to be truncated anymore, right? Without making this any larger than our previously sized debug event. So that seems good. And so I think what we want to do is this. So we can always use the block there, and then only this particular one uses two of them. And so it's going to use its own special version because it's got this bad chaining behavior we have to handle, right? But I think that's the only place where that actually has to happen. So that way we could do this and never have any truncation at all. Everything would always be full width, which is much better than what we had before. So I like that a lot. And then when we actually collate those inside the debug system, everything should just work. The only difference is now the block allocate has this sort of other weird situation going. So we've got the arena lookup block there. The rest of these can just use the block as is and be fine with that, right? Okay. Let's see. So let's try to make sure we've got everything going correctly here. We've got to do the arena removal, and then we've got to fix all of our errors. All right. So in debug record block allocation here. Also, I want to make sure that I made those macros correctly. Yeah, this should just be that. What is the question? BL. Do we have a capital BL being used there somewhere? Not sure I see where that's coming from. Am I missing something? It says capital BL? I remember 196. In debug record block allocation. There it is. I was looking at the wrong one. Okay, so let's make all of these things work properly. So in the arena lookup block here where we get one of these things, I think what we actually want to do here, let's see. So when we're actually looking these up, we just want to use a block address, and the block address has to be the address of the first block, right? So meaning we're going to be looking this up by this. And so we have to say, like, if test first block and test first block memory address equals lookup address, right? And so the lookup address is just whatever the block pointer was that we were asked to find. Assuming that we did find it, we go ahead and return it. If we don't find it, we create a new one, right? That should always work, except in this one case where we're not allowed to do it because we're not going to fill in a block. And if we're not going to fill out a block, we're kind of screwed because we need to look it up by that, right? So in here we get block free, move to free list. That should all just work, right? I think all this code should be fine. What's wrong with this? That should just be block. And that should just be block as well. In fact, that should be true everywhere. So that's correct. That's all correct. So I think we're good. And we just now need the ability to do the removal. Get arena by pointer is not what this is called anymore. And so then I think the only thing we need is this code. And so this needs to take the debug state and the arena to remove. And all we're going to do here is look to see when we find it. So basically, we're going to say that we're going to look at the debug state's first arena. We're going to look to see if we can find this particular one. So we're going to say, oops. So while we have one that's valid, we are going to we're going to kind of move through each one, grabbing the pointer. If we find this particular one, then we just skip it, right? I guess I could write this in a simpler way that doesn't require so much fancy footwork. I could just say this. If the first arena equals the arena, then debug state skips it, right? Otherwise, we scan. And this is just a little easier to read. If it's the first one, skip it. If it's any other one, just do the same thing and check, right? I was going to write them as one because you can do it by just using the address of the pointer, but I decided not to just for making it easier to read. So if the next pointer would have pointed to us, we just say that it points past us, right? And then we're done. So that gets it out of the list, and then we can just pop it on the free store, right? And so the only thing I want to do here is again just try to get it from a free store. So we try to get it here, and I guess I can just do it like this. So if we get it, and if we don't, we make a new one. I think that's all I really needed. And I need to put that someplace to actually store that in here. Oh, and I already did. So hopefully now we can actually debug this for real and make sure that we're actually getting the proper order of events here. That was what I was worried about before, so I'm just trying to make that work now. Let's see what the bugs we actually hit are first before I go tracking them down. Excuse me. So it looks like we've got a tracking problem with our first and last pointers here. You can see that these don't match. That was just an assertion designed to catch the fact that we're not tracking the last pointer properly. Let me go take a look at who's responsible for that. You can see that we're asking it to remove all of the allocations in our block here. So it looks like our free block in question is actually the thing that's wrong. So looking at when that's getting updated, there's two people who can be responsible for that. One is when we're allocating, well, I guess there's three people actually technically. So when we actually create a block itself, where's our block allocate call? Yeah, in here. We set them both to 0, and then when we allocate a block, I'm sorry, when we do an allocation, we need to update the pointers here. Oh, and you can actually see it's just a not. It's missing the not in that case. So the debug arena allocate just needs to update it when it's not set. And that was just a stupid typo, right? Okay, so yeah, I don't want to quite do breakpoints just yet. I want to let this thing run and see what happens that's bad. Okay. So now we're at a place where we actually get, okay, so we found an arena by a block, but there's no blocks in the arena. That's actually not allowed. So again, another bug case here that we actually want to fix. In fact, yeah. The arena itself did come back correct. So first block should never really be allowed to be set to 0. So in the case where we do a one of these get arena by lookup block, I think what I may want to do there is actually disallow creation except on a very specific type of call, so that we can have this error occur earlier in the process and debug it, right? So in here where we're doing this, maybe I guess what I'll do is like assert allow creation or results, right? Either we got one or you're going to let me create one, but not both. In fact, I could also do it this way, assert allow creation. So that way when we do this, we're just going to say most of the time you can't make one of these. In fact, the only time that you're actually allowed to make one of these is, excuse me, when we're getting it here, right? And so this, I'm hoping, will catch problems with the way that we're processing this, because it'll tell me like somebody tried to look up a block that they shouldn't have been able to look up, right? So let's see. It's in an allocation call, and it's trying to create a block for whatever this is, right? and we haven't actually gotten that block through here, or it cleared out all of its memory. Well, no, it would have had to have called the free. So we don't really know, right? We don't know why why we're getting this event without that information, but we want to know, right? So we want to know like what's going on here. Now the question is, how many of these have we gone through before we hit the problem? And I don't know. So let's find out. Quite a few. So we're like processing all of this stuff, right? And this is all not causing a problem. So we get to quite a few allocations in before we actually hit this issue, right? That's unfortunate. It makes it a lot harder for us to track down. But, you know, let's start by just going, what's the actual location who's causing the problem? Maybe that'll give us a clue. So the GUID is coming from handmade memory.h388, right? So it's another bootstrap, right? It's a bootstrap that's causing the problem. And it's specifically the first bootstrap that's causing the problem. I should say the first allocation in the bootstrap is really what I mean. So somehow, this first bootstrap push size, this one here, somehow that push size is using a block pointer that did not previously call the block allocate. Now, why would that be? Tell me more. It's the very first allocation in a bootstrap. It did allocate 32 bytes of memory. And somehow it did not hit, or this did not properly work, this part of the code. So why is the question? Why would that be the case? Let's ask another question. So here we've got, in fact, I could even look at these a little more closely. So since it's only the one bootstrap one, I'm interested to know how often are we bootstrapping and which ones of those are having the problem, right? So if inside the bootstrapper here, if I just like say, let's go here first, 1, 2, bug. So I know there's only 2 of these that actually happen. I can step through them, write down what they did, and see why we're getting an error. The first one attempts to record a block allocation here. The arena setup is as follows. You can see that the current block would be whatever I just recorded here. So it's, 2E1476F0000, right? So that's the block allocation that should be entered into the list right now as going with the, this operation here. And it will record the prev block as well. So the one that it'll use for lookup is actually 0. Which should still work okay, oddly enough. We'll get to that in a second. I then come through and I'm going to go ahead and do a debug code allocation here. I look at the current block, and the current block does correctly mirror this. So there should be 2 events in the debug stream back to back. And honestly, I think I can even verify that, because if I look at the global debug stream, where is that? If I look at this, this is going to be kind of tricky. So it's 82, which means I should be able to just do this. Right? So this is the first one. This would be like the next one that we would actually record. So we actually want to look at the one just before that and the one just before that. So number 80 in this case, right? Here's the block allocation, and let's see what it said. It said the lookup block was 0 and the block was, F0, which is exactly what we would expect. Let's see what the next one says in this case. And in that case, we've got that block is recorded correctly as well, right? There's the F000. So those are both recorded properly. Let's see what happens the next time through on the push block, the push size for the bootstrap. Let's see, we've got the arena current block to DD0000, right? So that's the second one. That's that one. And so what we want to do here is say, let's just remember which of this was the first, this was the second that we hit, and there's only 2. So then when we go into record the allocation here, we're going to use the current block. It is correct. So again, those should be correct. 1661 should show us that as well, right? So that should be the block alloc. Looking at that, we get a 0 and a DD there, which is exactly what we want. And then if we run it and record the other event, I should be able to get, oops. It'd be nice if cursor positioning worked in, what is it, Dear I Am GUI, or whatever it's called. So yeah, looking at the memory op here, DD0. So these are totally correct as far as I can tell. So it looks to me like we just have a bug with how we're processing the events, because the events look like they should work. So give me 1 second here. I just want to look into the debug's system's handling of these. So inside block allocate, this is going to get passed to 0, which should hopefully mean that it does actually allocate one. it will then go ahead and make the new block like so. Either way, it'll say there's no allocations in it. It'll take the block that was passed as the new one that's going to be there, set the memory address to that, which is what it should do, and then record that that arena's first block is this one, right? And again, when we're scanning for these, that's what we're using, right? We look through the arenas and we look for the first block, and assuming that there is one, we test to make sure that the memory address is whatever address you asked us to look up. And then when we add it in here, we just say, yeah, like, take the first free one and use it. That all seems fine to me. Oh, hi. That's pretty stupid. In the case where we reused one, we never actually bothered to set its state. You think that could have something to do with it? Yeah, probably. All right, but it does seem to be working okay so far, so let's see now if that tracks it properly. And we can sort of see how onerous it is later. All right, so now we seem to be going okay. If I go ahead and switch us to release build, we can see whether we have any horrible memory runaway happening here. Seems reasonable, but it looks like we are sort of maybe leaking a bit there, or doing something that, right, like watch. You can almost feel it when it happens. Yeah, I mean, just look at what's happening, right? So we're not quite processing that correctly, but we're close. Okay, so let's try to just isolate our memory error here, and then I think we're good to go. And this was pretty tricky to get right, to try and track all this without actually intruding at all into the thing we were tracking, but I think we did it. Unless there's a gotcha here that I didn't anticipate. But yeah, so if we look, yeah, we're properly calling all of this out. All right, so if we look at what's happening on all of these, let's just double check our process, and then we'll make one more pass in the debugger and see if we can get it properly. Okay, so first things first, here's where we manage the arenas. So in here we say, okay, look through all of our arenas, see whether or not we've got one here. This actually should never be allowed to be 0. So in a sense, we could just do this probably for starters. Let's do that and just make sure that's true, because you're not really ever allowed to do that. You're not allowed to leave somebody in here after the initial add who doesn't get their block pointer set. So that's, should just be the case. When we come through here, we say, look, are there any free ones of these that we can grab? If there are, great, use it. So we advance the, we pop it off the free list, basically. Otherwise, just add a new one on here. Either way, we set the name, initialize the fact there's no blocks in it, and then we chain it on by saying the first arena points to it, I'm sorry, that its next pointer points to the first arena and the first arena points to it as a standard linked list addition, right? For setting the name, we don't do anything. We just look up to see whether or not there's a block pointer that's valid, and if there is, we just set its name, and that's all we do. So we shouldn't really be able to do anything there that would cause any memory to exchanges to happen at all, and since we're not even allowed to allocate here, we would get an assert if it did. Moving stuff to the free list here, this is probably a place where we could be having some serious problems because we need to make sure, we need to do this very carefully. So if we have a list where we've got a first and a last here, and what we're doing is we're saying, okay, if there is a first pointer, then we need to do some work. Otherwise, we don't. But we want to make sure that there's no last pointer in that case. So assuming there's a first and a last pointer, what we do is say the next, so from first to last is a chunk of these links. The next pointer will point to whatever the currently first free allocation is on the free list. And then we will point to the head of this using debug state first free allocation, right? That seems correct to me. I don't see anything weird happening there. So that all seems fine. When we go to remove an arena, pretty straightforward process. If it's the first arena, then we just move the first pointer to whatever was after it, right? Otherwise, we start by looking at the first arena and we go as far as we can go. Yeah, we just look and see if it was the next pointer. We then hop over it in exactly the same way that we would have done here and stop. We then set its next pointer to point to whatever the whole chain of currently free arenas were. So we do that. We then say that the debug first free arena points to the arena, right? To the arena itself. Maintaining the free chain. In debug arena block free, this is taking one of these blocks and getting rid of the whole thing. So what we want to do here is move everything to it, which is what we do, right, at the outset. And we're just asserting here that that it is the top block on its stack. So we do this. Of course, that would have to be true. So this assertion is kind of pointless, but you know, whatever. In order to remove the free block from the arena after we move all of its allocations off of it, we say that the first block on the arena is whatever the next block after it would have been. That seems fine. We then add the old block to the free list. We do that by saying its next pointer is whatever the arena block free list previously was, and then the free block points to us. We then say if that would have been the last block, then get rid of the arena entirely. Right. Now for truncation. So this is quite possibly where we would have problems. So here we say, all right, get the arena by the block, assert that it's the block we want. We're going to start by looking at the first allocation, and if the first allocation's offset from the block is less than the total size, then we know that this is a valid allocation, right? And the question is that check going to work? If we're always pushing allocations on in the reverse order, so like allocations come on and they get added to the front, right? Which we did. You know, that we did make it so that every time you allocate, it's the first thing. Nope. It's the first thing on here, right? So they should go in ascending order. So if this block is less than the allocated size, then none of the ones after it should be either, right? We could add some assertions if we want to double up on that, right? But anyway, what we're trying to do here is say, all right, so assuming that was the case, we just stop, and that's the end. But if it's not, then what we do is say, well, we could free this one. So advance the pointer and remember that we could have freed this one. If we get to the end of this and we find that the first allocation in the block is not the one that we ended that iteration on, then we know that there is a range we could free. We move everything from the first allocation and up to and including whatever the last free one was. We move those to the free list. We then make the first allocation whatever this first valid part was here. And then we say if the last allocation was the one that we would have freed there, then we now have no allocations left in the block whatsoever. We don't actually deallocate the block because we assume that it will tell us to do that in a call to block deallocate, or block free, rather. We assume it would have called this, right? Again, seems pretty solid. Arena block allocate, that actually has to make a new one of these. It first says, can we get a free one? If we can, just advance the pointer for the free list so we get a different one next time. Otherwise, allocate a new one. Initialize its stuff, put it onto the arena's first block here. And we know that must at least be working because otherwise we would get assertions when people were trying to use the memory address there, right? So finally, we're down to allocate. We get whatever the block is that we're supposed to be putting this one on. Inside the arena first block part here, what we want to do is say, yeah, make sure we're on the one we think we should be on. Then look to see if we have a free allocation. If we do, then move the free list up one. If we don't, then make a new one. Record the allocation by saying that the GUID for this allocation is the GUID from the event, that the offset is the offset, the size is the size. The next pointer is going to be whatever was previously on the blocks list. The block's first allocation I think I just realized what the problem is. I don't actually think there is a memory leak. So we use memory arenas inside the debug system, right? So this will always create an infinite loop of allocations, because every time you allocate, you record an event which has to allocate another record to store it, which will create an event, which will create another allocation, right? So we can't do this for things that are in the debug system, right? If we do, we can never record them all because the act of recording creates an event, right? So we need a way of telling the system when we're allocating these, please don't remember that. So yeah, that makes it a little tricky. That's awesome. That's so cool. So probably what we would need to do there is this. Everybody, when we do the get arena lookup by lookup block, I think what we have to do there is essentially put in sort of a suppression operation. So when you query this thing, you might not get one back, even though, you know, that doesn't make any sense. Well, it does, because we're going to have to suppress any calls that came from the debug system in the first place, right? In fact, I guess there's maybe one other way we could do this now that I think about it, which is when we actually go to dispatch the event, right? We could look to see whether this event came from the debug system or not, and if it did, we just throw it out if it's a memory op that came from the debug system itself, right? And the way to do that, I hope, Although now that I'm saying that, yeah, if the debug system calls something that's outside the debug system, that would work. So I take it back. I do think you want this, right? You want something which basically guards all of the calls on if arena, right? And then in here where we actually find this stuff, right? What we would do here is say, you know, if result suppress then it's 0, right? And so what we would need here is we need the ability to set an event that basically says this arena cannot ever, like, don't ever let this thing do anything, right? And so when we get this event here and we get the name back, what we want to do is probably also be able to set a suppression event here. Don't ask me why I spelled that wrong. Something like that. So if we set that secret flag in there or something, then it will, you know, allow us to suppress this arena and stop recording the events on it. Because yeah, that's sort of hilarious. I was just like, wait a minute. Even if we don't have any bugs in this system, it will still fail. There is no way to record the recording system for memory because just the act of recording it required the memory, right? And so, yeah. So anyway, I think that should be fine. And then what we want to do is when we initially create the debug arena, we just need that arena to be suppressed. So both that and the per frame arena will always be suppressed. And since there's only 2 of those, I don't actually know where the per frame arena comes into play here. But we want to suppress that one too. Even though that one technically is okay, because since we don't allocate from that one, we could still, like, track it. I just don't want to because, in fact, where... So that's in store event there. Yeah, so the per frame arena, I don't know where we have to wipe that one out though too, don't we? Like, how is that one being used exactly? Shouldn't there be a place where we clear that? Oh, no, so we don't really do that, it looks like. So it looks like more what we do there is we do allocate from it with a store event, but we just recycle. So is there a reason why that's... Is there a reason why we even have that anymore? Interesting. So we don't really need these 2 arenas. We only need 1 now, right? I want to say, can we just do this? Because I think so. Yeah. I mean, I think we can just get rid of it. So let's just do that too. While we're at it, and that just simplifies things. We only have to suppress one arena. And then nobody cares. I think. I hope. So now we just need that suppression call, and that seems pretty simple because it's basically the same call as the name call. And so I think all we have to do here is just say arena suppress. And then this just needs to set the little secret special sauce. Oops. Right. So I think that would allow us to suppress those messages so that nothing would actually happen there, I hope. Right? Yeah. And so I think we're good now. Those will all get named, and then that one debug one would get properly suppressed, I think. What's going on here? Hold on a second. Looks like we've got somebody who's doing an allocate there that shouldn't be. Who is it? So I guess, yeah, you know what though? I guess the problem there is we still do have to sort of track them a little bit. We can't detrack them entirely. So we do, unfortunately, actually have to remember how many blocks there are, because otherwise we don't actually know. Yeah, like we don't actually know who to suppress without tracking the blocks. So I guess we do have to do a thing which basically says if arena suppress here, and then everybody else actually still needs to do all the same work that they were doing. Right? I think. Block allocate, block truncate, not so much. But everybody else, yeah. Man, this is crazy. If this ends up working, I'm going to be pretty psyched. Because this was a nutso thing to try and do. But, you know, sometimes it's fun. So that's all good. So we just don't track the allocations, but we do track the blocks. And the suppression should stop anybody from going crazy with that. And you can see us now being stable here, it looks like, which is good, right? Let's see if it climbs too high there. It should go for a little while and then level out once the debug system starts recycling events. And that's just climbing too slowly for me to even really tell, so I'm going to go ahead and crank it into O2, and just so I can see if what our memory ceiling is there. Wait, where are we? How come we're not showing up in here? What the hey? There we go. Good, so now we're nice and stable. And in theory, tracking all the memory. So now we know exactly where all of our memory is and who allocated it, right? And so in theory, I want to say that then we can just go ahead and take the profile information like we were doing here, where we created like a profile group. I feel like we can then just put, you know, like debug state memory group like this. And so in the like profile group, I just say like, all right, make one of these things where we're going to have a memory display that just hangs around and does whatever it does. I like how we actually didn't even have the macro for that. It says this system needs a cleanup someday. It's close to being good, actually. It's not that far. It's just a few bad decisions that if you just undid them, it would be pretty sweet. So I think that we just need to, you know, be able to add to the this root profile event bit here. I'm just not sure I know how you set that up because I don't remember how we were doing it. I'm gonna look and see who actually mucks with that and how they configure like what it's gonna show, you know. Like, I don't really know. Like, how do you tell that thing that you want to see, like, the frame display and stuff? You know what I mean? I have no idea. It's all just is very unnecessarily complicated. Because, you know, like I want to be able to do that for the memory group, and I just don't actually know, like, how did it know that? Here's the root group, here's the function group, here's the profile group, right? The profile group is what you would be viewing, and somehow that thing knows what it should do, but how did it know that? Does it get set somewhere? Apparently not. Yeah, so I just don't know how that ends up getting set. Because, like, just to sort of explain what I'm not remembering about how we did this stuff. I thought you needed to set a thing like this dev mode profiling thing, right? This is what it sets when you want to look at that. When you want to look at that using the debug system, you know, it just sets it here, and then that's what the thing uses to determine what it should display, right? That's how this thing works. So, at least I thought, but maybe that's not true. I guess I could look at debug mode profiling here and see what it actually does, but so I guess this is how we did it. Okay. So I guess if we want something here, we would say, like, here's the memory view. I guess. And then here we could say I don't know what this means either. Probably just a name, I guess. So I don't really know if this will work because this is weird. And kind of stupid. Yeah. So what I want to do here, right, is I want to now have a way of viewing what these arenas actually are showing, right? What they're tracking. And there's a lot of different ways that I can do that. But what I want to do first is just do a simple summary view. So if you look at what happens here, right, we've got like top clocks list. I don't know what debug memory info is. Oh, it's that element that just prints like the basic information, right? Like if you look at the profile view, here's what we kind of stacked up on there, right? And so those calls create this thing. That's the frame slider. That's the last frame info. Probably here. Although, I don't know what last frame info is because I don't know which one that this is, if it's last frame info or debug memory info. I'm not sure. And then the top clocks list is this thing, right, with these buttons on it that kind of shows us what the profile looks like. And so what we want to do is probably something similar to that for our arenas, right? And so I think we can just, yeah, the name came through there, so I guess we just want to say like, just gonna call this like used memory or something. I don't even know. But what I should be able to do now is kind of just copy that list. So like inside the debug system where we actually draw the top clocks list or that kind of stuff, right? So in draw top clocks list, you can see where we're sort of placing these pieces of information. Like here's all that stuff. And the top clocks list itself, like you can see here, we create some buttons that allow us to like switch what's actually going on. And we probably want that to be the case with the memory system as well. So I'm just going to go ahead and say that we probably do something like this. Right? And I guess the graph, there's the debug view profile graph thing here. We've already got one for arenas, so we should probably use it. I don't know what we're going to store in there, but probably something, right? And so when we do this debug memory info, when we encounter this, we probably want to put the stuff we want to have here. So we can say like, arenas or like, totals, arenas, frames, or totals, or or something like that. I don't know. And then in here, when we've got these debug types, instead of memory info, what we would do is say like which ones we actually wanted. So where we say debug type, debug memory info, that's actually going to have like a couple different things. So like this would be like debug type arenas, debug type arenas, like maybe arenas by frame, arenas by arena, right? Or like memory by arena, memory by frame, memory by total, or by size. Something like that. And so that we could just have those work the same way the other stuff works. So in here, like get rid of that. And just say, give me these sets here. And that way when we print this out, we would say like memory by arena, by frame, and by size. You know what I mean? All right, and so we probably won't implement those. I'm already way over time because I got kind of a little too into it, but that's basically all I want to do. So here we would say like memory by size or something like that, probably, maybe. And we'll just do a really basic one now to see if this thing's working at all, and then next weekend we'll do the more fun version. So let's go ahead and say that I don't know what this is going to do right now. That's probably going to look at what arena we're actually talking about here. So I'm going to leave that root button out. We probably will use it eventually, but for right now I'm not going to bother. And what we should see now is that if we actually look at the memory graph, well, that didn't actually do even remotely what I was expecting. How did it even draw that? Who is calling draw arena occupancy in the first place? Because nobody should be. Oops. Okay, so arena occupancy. Oh, wait. So did I do something stupid here? I don't think I did. But that was actually a different type. So that was actually something that was in here and just not used. Right? Which is nuts. But okay. So basically this in the profile, I totally just, because there actually wasn't one of those. So arena occupancy needs to go away. It's not a thing. Yeah, so this whole thing needs to be saved for later, is I guess what I'm saying, right? But that is kind of what I wanted, so I want this to sort of be what we would base the code on, right? So we want to save it. I don't want it to go away. There we go. And so, yeah, we do actually want this stuff to do something eventually. Right? So now if I run it, I should get in the profile, it should just be what it was before, which it does look like. In the memory subsystem, I should just have these, which I can pick. Now, unfortunately, that's actually switching me to a totally different type because I didn't actually correctly make these. So I want to actually have these set to memory by arena, memory by frame, and memory by size. And then I do want this stuff to happen as well. So basically like this. Still pretty much wants to happen. I don't know what this value wants to do with its life, but probably not much. But these are going to be the things where we actually call out to some function that visualizes the memory somehow. And then, yeah, I don't know what this is supposed to be. Yeah, and this stuff didn't mean anything anymore. That's why we got rid of it. Okay, I see. Yeah. All right, so that's just done. So I think this is everything we need now. So we've done all of the infrastructure, we have all of the information, and we just need to do the visualizations now. And we can totally see what's going on with the memory in theory. And so we can, much like the one we did before, we should be able to, like, you know, do it just like the profile where it comes up on there, right? And so if we wanted to do memory by size, top clocks list is basically, you know, it's basically what we want. And so I feel like we should be able to do something where we kind of, you know, where we just use the same process, probably. So like if I was to literally just clone this guy, right? And I don't know where the memory stuff was at the moment, but so if here I just said like, okay, go ahead and do a draw, an equivalent, right? Of this. Sort of. If I wanted to do the same thing, I feel like I probably just could. So we know how many arenas there are by doing the exact same thing we're doing here, right? So we could say debug arena equals arena, you know, debug state, first arena, arena equals arena next, right? I mean, that counts the arenas. Same thing. We can create the sorting situation here. We can walk through these. We can do the radix sort exactly the same way as we were doing it before. In theory, I think. Yeah, and then I think we literally can just spin through these and write it down. So for every one of these arenas, in fact, you know, this is literally exactly the same. Right, for every one of these arenas as we go, we just need to track the index here. So for every single one of these, I think we just do the same thing. We just say that we have a total amount of memory. I don't know that the R64 needs to happen. Oh, for the statistics it does, though. So I think we just do the same thing. We just say total mem equals 0. Don't ask me what the F's doing on there because it's a double. But for each one of these, we just say like, okay, whatever the entry element is, that's probably this. And then we just do the stats from there. So the entry arena is just the arena we're talking about. We don't need this. That all works. We then say the debug memory block, or sorry, debug arena block. And we don't really need to know, I mean, we could sort on two different metrics here, I guess. We could sort on the total amount of used memory versus the total amount of allocated memory. And so I guess the statistic here isn't necessarily all that useful. For us. I want to look at this. Actually, no, that seems very useful, so I'm going to use it. So what we do here is we say, okay, we're going to accumulate our debug statistic here for the min-max sum average count situation, right? I could keep two of them, one for used and one for total. I don't know which one I want to do or if I want to do both, but maybe I'll do both. So if I came through here and I said what we're going to allocate versus what we're going to use, for each block, I know the total that's been allocated because I can just say that the debug information keeps that explicitly, right? It's the size allocated inside the block. So I just do allocated and used as my two stats. Like so, I think. That seems right to me. Yeah. And so for each of these, I just need to do the actual accumulation. And so for the allocated one, it's just the size that was allocated, which we always know. And so here we just have that. For this one, we actually need to do an interior loop, right? We need to say arena allocation and in here we just say go ahead and accumulate whatever that allocated size was. And I think that's all we need. The total amount of memory allocated and the total amount can also be tracked through the process by just doing it here, right? So the total allocated and the total used can just be summed up. We probably should just use 2 levels of statistics for that. I'm not sure why we don't, but we don't. For the sort key, what we want to do here is just take whoever is largest. So I guess it goes in negative direction, so I guess we do want this. We probably want allocated, but we may want to do used as well for later. I don't know. Once we do the radix sort, I guess this is us kind of doing printouts here. Not sure exactly how that wants to work. If the total time, it's 1 over the total time, so this would just be like the total allocated, right? But that's like the percentage, so that's the percentage total allocated. Percentage clocks is probably what it meant. It should be PA probably now, if we were being pedantic about it. So once we come through here, we should be able to do like allocated and used, like so. And we know the arena because we kept that information. Again, the running sum, I don't know which one we want to do. That's why it's a little confusing, but we could use allocated for now. We then want to go ahead and put a, sort of a way of printing out whatever this information is, which I don't really know exactly how we want to do that. But in terms of what we've got to show, we pretty much know, we know like how many blocks there were, which is I guess another thing we should have probably counted. In fact, let's count that. Oh wait, we do know that. So in here, the count on the debug statistic for allocated would tell us that. So basically what we would want to do there is just say, yeah, like, I don't even know how we want to show this. It's kind of complicated. So we've got the arena name, which, may or may not be something human readable. We hope it is, certainly. And then we've got a bunch of information we can print out here, how many blocks there are, all that kind of stuff. So I don't know what we want to do with this number for %10 UC, Y there, or whatever, but probably we just want to do like the megabytes of the thing. So we would say something like megabytes there. And so we would say like the allocated sum, divided by megabytes. That casted would give us a megabyte number. It probably doesn't need to be 10 long because how would you allocate that many megabytes? So what we want to do with that is probably print it out in something that's like, nothing's going to be more than a couple gigabytes even in the most ridiculous scenarios. So we're probably talking about something like a %4 there, right? So then we've got our actual floating point number, which is going to tell us now what percentage of the allocations total in the system this was taking up, right? And then we've got information like how many allocations there were and how many blocks there were and stuff like that. So we could do, for those, like, we could say the allocated count and the used count. I don't know. I'm going to get rid of this for now. But we probably do want to hover. Tooltip on that at some point. That's off the block. My bad. So the radix sort needs arena count. Same here. And the PC is PA. All right, so let's just see now if we've got anything resembling anything here. I don't know what temp name is for, but it was probably for constructing the name of the thing, which we don't actually use. We just have the name now. So off we go. And let's take a look at what that actually displays. Okay. Well, displaying nothing was not what I was hoping for, in case anyone was wondering. But to be fair to me, if you want something to draw, you have to actually call it. And so one of the things that you will learn about CPUs is if you never tell them to branch somewhere, it turns out they usually won't. Now, sometimes they still will, but usually they won't. So let's try that one more time and actually try calling our function this time. The debug element root elements is not actually something we need, so that should probably go away. We do want the rest of this stuff, though, to be occurring. So yeah, we want that to happen. If I go look, I want to see how we're calling top clocks lists to make sure we're basically calling it the same way, because we want this to be effectively the same thing. So when we call top clocks list, we're calling it with the debug state, the debug ID here, the layout elements boundary, and the mouse P from the layout, and that's it. If I go back here, I'm just going to get rid of that root element because that shouldn't be used. We have the arenas in a separate storage location. And so now let's see if we get anything. We've got a problem with our printout. Oh, and yeah, we sure do. So I forgot to, I said %4, but I didn't actually say what it should print it as. Where is that guy? So that wants to be an unsigned value there. Try that one more time. All right. So looking at this stuff here, we should probably name the suppressed one. And we've got two that didn't get names. We might want to try to figure out how to associate the names with them. But you can kind of see now more or less probably exactly what you would have expected, right? You can see that the debug system tracks like a lot of stuff, so it's eating up a ton of memory. We don't care about that as long as it doesn't crash our system or something because it's just debug. The game itself is running in 69 megabytes of memory right now. There's a frame temporary storage that's sitting at 2 megabytes, but it's important to remember that we probably need some additional statistics tracking to actually know some of that information, because by the time we come back around, we may, because it's constantly getting like used a little and shrunk back potentially, the 2 megabytes is like what it ends on before it gets flushed for the next frame, but it could have like used quite a bit more than that. But anyway, so you can now see exactly what those memory layouts are and who's using what memory and for what. And this is exactly what we want to see. We want to see basically, we don't care about this, the debug one. We want to see like everything in asset storage, because the best possible scenario for our game is we just use as much memory in the machine as we can to store our assets, and nothing gets used for anything else, right? No pigliness anywhere else. And so there's our memory sort of analysis there, right? And so if we wanted to draw the arenas, that would be more similar to the thing where we're drawing like the frame layout, and that would show like who was doing what in each of those arenas. doing that, I don't know how hard that would be. I'll take a flying leap at it now. What was I going to say? Oh, let me add to that suppressed call the actual name. And so when we have in the debug interface, when we suppress the arena, I'm going to go ahead and give it a name as well. So in here where we do debug arena name, I'm going to do that, right? And that way we can properly mark it as the debug arena, and that'll be good, right? So let's see here. Where the other arenas are coming from that are still persisting, I'm guessing maybe they're ones that are coming from like maybe the platform layer. I don't know. We'll have to go see who they're coming from, but it should be pretty obvious eventually. All right, so now what we should see is like the debug one is properly marked as debug, which is fine. And we may want to remove that one as well. So we may want to have a toggle here that says whether you want to see that one or not. And so that way you can look at your percentages without debug sitting in there, like sort of crunking it up, let's say. So what I want to do now is just take a flying leap at putting in the occupancy version just to see how it looks. If we take a look at the profile version of this, so we've got the top memlist version. This doesn't need to be here, does it? Anymore? No. So if we look at how this one's working, we've got the thread interval graph is really the one we want to look at there. And so I want to do the same thing I was doing here and do like draw arena interval graph or something. And so at draw top mem list, in here I want to do the same thing that I was doing there, only now it's called this and not that. And then what I want to do is I want to go to that draw profile in thing, and I want to do the same thing, right? So I want to take one of these profile bars things and like figure out how to get these two working. There we go. So if we're going to do this, we need to know how many lanes there are, but the number of lanes there are is just the number of arenas there are, right? And so we could just make a thing that's like, how many arenas are there? And the number of arenas is this. And we could even cache that value if we felt like it. So for some reason we didn't want to loop over them, but you know, it's so few of them, it doesn't matter. And so this way we can just ask how many there are. And when we then go through and draw these, so we've got the lane count and the lane height stuff, that would be basically the same. So we could just say get arena count for the debug state. That'll produce the lane height for us. The frame stuff, so really what we would need this for is if we wanted to like zoom in on blocks or something. And honestly, that just doesn't seem particularly plausible to me. I'm just trying to think of how you actually do this, because the way that this works is you want to be able to like see the blocks and see where the allocations are inside the blocks, showing just the blocks at first, and then you click on a block and it shows you the block. Maybe that makes sense. So I think maybe that's what I should do. I'll be honest, that doesn't really make any sense to me anyway. Because why would you care about seeing the blocks? The blocks are just a list of blocks. Like, who cares about that at all? So you really just only need to see the individual things. And so I think what you want more is just to be able to pick a particular arena and then just see its layout. I mean, that's really all you need. And so I think, like, honestly, we don't really need a draw memory bars call here. I can just go ahead and get this out in its entirety, I think, I want to say. And then I'm going to dump that in here, and we're going to take a look at it. So I think, yeah, like, we just want to know which arena you're trying to view, and maybe we just draw those as little, like, bars you can then click on. And assuming that you click on one, we then see which one it actually is, I guess. That seems like the best thing, maybe. I don't know. So maybe what I'll do first is I won't even do that, right? Maybe I'll just do a thing that's like, look, maybe all I'll do is I'll just draw like all the allocations as a bar in here, and we'll just call it a day, right? And we'll kind of figure out what we want to do after that. So if we actually do this stuff in here, this is mostly all we need, I think. We don't need a depth thing. We just do that. All of this goes away, I think. And so really we're just mainly talking about this stuff, right? We're going to pull this. Well, no, we kind of want this. So what I want to do is for each arena, I want to go through each block. Oops. And then I want to go through each allocation. Then what I want to do is I just need a way of creating whatever the rectangle is going to be for that allocation. And if I just divided it up along the screen, right, I would have a bar and each chunk would be one of these allocations. The problem is I don't know how many allocations we have. You know, if there's thousands of them, they're going to be too small for you to actually get into one and pick. But, you know, I could just have there be a zoom factor that you could use to zoom in and out on them, and maybe that's sufficient to solve that problem. But the other way to do it would be to actually use the full 2D space and like actually sort of just stripe them in there. And you draw like multiple rectangles if you would fill more than one row or that kind of thing, right? And so, you know, that does seem like something good, probably. I don't know. Using the color table here also would be good, but would probably just do that by which index we are on the actual allocations. Probably. Just guessing. So this would probably be something like this. This part is the part we don't really know exactly how we're going to do it. The lane index is just going to be whatever arena you're in, though, for now. Right? And then most of this stuff can pretty much closely resemble what we're actually doing here. We don't need the get name bit, I don't think. I think you just want to see that GUID because it's constructed for just the name by itself. So my assumption is you don't need that, but I could be wrong. So yeah, so I think we don't need this. We just need that. That's what you wanted to know. And you want to know what the allocated size was, right? So you want to know for this allocation, what were you actually looking at here in terms of bytes, right? So you want to know like exactly how many bytes there were in this particular allocation. We don't need that to be formatted out that way. It can look like this. So assuming that we print that out, I don't think there's any way to zoom on these. So I think that's just a non-issue. So I think we're literally just looking at that. And then for each of these, what we really just need to do is figure out where the heck this thing goes, right? And so for each block, what we could do is just say, well, maybe the block, since we know the total size of the block, we just draw the block and then draw the things inside the block proportional to where they were, because that is the information that we needed, right? And so what we don't really know is how big the block should be. I could count the number of blocks and do it that way, or I could just keep stacking blocks until we run out of room. I don't really know. That's a kind of weird situation I don't know the answer to. Maybe what we'll do is exactly that, though. So we'll basically start the blocks off at like 0, 0 or something, right? And relative to the profile rect, I mean. In fact, I suppose I should actually just do it that way, right? So the profile rect min x, profile rect max y is where this thing starts. And each time we record a new block, we just like go to the next thing. I could on here also say like which arena it is. So we could say like arena name, something like that. So I can use the double string there. So we'd have like arena name and then the GUID that it was and how many bytes was allocated for that thing. And then we just need to know like for each block. And I guess that gets rid of the lane thing too. So we wouldn't really be using lanes. We'd just be showing blocks, right? And so this whole thing would go away for the most part. And we don't care about that. We just do this. So we need to know like what the block dimension is. So we need to know like how big is a block. And I'm guessing that needs to be fairly wide but not particularly high, right? So maybe we say like we want the profile rect, like maybe we want to get the width of the profile rect. And then here we want to say something that's more like a fixed size, right? So, you know, I don't know what this is, but maybe it's like, you know, just 20 high or something like that. And so the get width here where we do, excuse me, where we get the profile rect, we just say, look, we want to fit like, you know, some number of blocks across. So we just divide by that number, and that's the block dimension. So when we want to know how big a block is, we do it here. We also know that since it's 4 wide, every 4 we could reset. So I guess what we'd want to do with that is like block index as well. And I suppose that means we also could just do it this way. So when we do a block, we know where it is. We just say the block can be constructed from a rect min max. In fact, we could just do it this way. Here's the block. That's the block rect. On here, we say we want to know, like, we know what the dim is, so we could really just say rect. We want rect min dim, really. Yeah, there it is. So what we would do is we'd pass the dimension, which is this, and the upper side of it is just going to be whatever our current y is, and then the block index times the dimension, right? So that's how we would stack blocks up, and we can make that a little bit better in the future. We'll do some dressing on that as well. But that way we have the block rect, and all we really need to do on the y is say like block y, and that's going to start out with the profile rect max y, right? So yeah, actually, sorry, minus block dim y. So it's, you know, the first row of blocks starting at the top. Each time the block index goes up over 4, though, we now need to advance it. In fact, I guess I'll do that at the bottom. I'll just say, like, you know, block plus plus block index. If block index equals 4, block index equals 0, and then we do block y reset, right? Oops. So we just move it down a row each time. So then we would need, for each allocation, to figure out where it is inside that block. But after that, we're good, right? So we really just need to be able to create a barycentric rectangle out of this larger rectangle, right? And we know what the proportions are because, well, first of all, we know that we're going to use the full height of the thing, so that makes that easy. But in terms of what the percentage is, like where we are inside that rectangle, we know we've got like a sort of a T-min and a T-max, right? And what those are is inside our allocation structure, we were already storing what we need to know where in the block we are. We're storing the offset from the block, and we're storing the size allocated, right? So we know that if we add these two together here, we have the max, right? And if we look at this one, we have the position. And so all we really need to do is we need to have a scaling value that's sort of the inverse of the size of the block. Well, we know what that is because each block itself has its size allocated on it, right? So whatever that size allocated is, we could just say like im size allocated. And we could say if the block rect has any size allocated, which it pretty much always should, we just go ahead and take the inverse of that, right? So then every time we want to compute one of these, we just say, all right, convert it to an F32, and then actually just compute the ratio. This tells us where inside the rectangle we are for this particular thing. We know the upper and lower bounds. Those are obvious. So we really just need barycentric. That makes me grumpy. So, what do I want to do with this? I don't really want to lose what I was typing in here because there was a fair bit of it. Although I suppose what I could do is take a screenshot of that. What's the easiest way to do that? Yeah, that works. I don't know how much I had there. Can we show me where that was? It should be errors there now. So what is this function, draw arena interval? This is still here for no good reason. All right, so we've got this stuff is still there, but we lost this guy, right? So I should be able to type this guy back in here and go from there. Toggle full screen. There we go. So let's see. Inside toggle, inside draw arena interval, or draw top men list, I guess is where I'm starting there. So draw arena interval, debug state, dev ID, graph ID, rectangle to profile rect, and the mouse P. All right, and so do I actually need alloc index? I do, because I need to know what color it's going to be. For block dim, I need the width of the profile rect. I need the block index, and I need the block Y. Then I need to loop over the arena. And track the block Y. That seems fine. We may not have a get width on that. I think it's just get dim. Right? Yeah. All right, so we create the block rect. We've got the in size allocated. Oops. Do we have a safe ratio, right? So it's really just that. So in this case, what we want to do is say, well, whatever the block size allocated is, that's what we're trying to do, right? So that seems fine. And then I just want to loop through the allocations. Debug arena allocations. And then the color is the color table. Like so. Our tmin, we know what that is. Our tmax, we know what that is. And then this stuff we didn't do. Like, this is nonsense code. So we do need to do this part, but we need to compute the rectangle first. So we don't know what region rect is yet. The base z part also I don't think we need to do for this because we're not stacking things on top of each other at the moment. The color in this case is probably, well, I can just grab this from the existing code because that's how that worked. Let me actually delete this temporarily and just in here do a if is in rectangle region rect mouse p, and then here we'll just do a tooltip buffer text buffer equals add line. And then we'll do the format string text buffer dot size text buffer dot data %s %ub arena name. This is actually the alloc GUID and the size allocated. Okay. So I need to go and cut and paste the region rect part there. Right. Also, this needs a termination from that. So in the draw profile in or bars or whatever, the part where it's doing this, we need to capture this part here. The base z is just stupid stuff. I don't think we actually need that. So I'm pretty sure that you can just get rid of this for now, would be my assumption. Like the way that other people are drawing stuff, right? They don't need to do that. And so I'm pretty sure that that part is not so important, right? Yeah, I mean, I don't think you need any of this. I'm not sure, but I don't think you need it. So I'm just going to get rid of it for now. And then if we have to change that, I will change that. So how are we doing here? If we push these rectangles on and have a little party, is everything going to be okay? What else do we need to know? So render group, region rect, UI. So those things we need to get out of the debug state, I assume. Yeah, so this stuff has to come out of the debug state. What else do we need? So then I think we're down to just the barycentric version. And so I think, yeah, it looks like we did this already. So the barycentric version is good because it means we can just sort of get the min and the maxes that we actually need. So what we should be able to do here is say, hey, give me the rectangle min max. Let me go ahead and get those out here. So let's get the min and max like this. So we have this block rect. And what I want to do is get the barycentric location inside that rectangle. And the way I want to do that is, you know what, I guess I don't even really need to put these there. I could just do this. Right? So the first things first, from getting the minimum, the x minimum is going to be the t min, the y minimum is just going to be 0. The maximum is going to be the max we computed and 1.0, so because we want the full height of the thing, right? And so at that point, I think that gives us our region rect, which is what we actually want, and then we're good, right? All right, so I don't know if this will actually work or what it probably won't be a very good visualization, but we can make a better one next week. So inside arena, oh, and of course, I should remember to call it. I did remember to call it before, but then we crashed, and so now I have to remember again. So I think we want to just call draw arena interval there, and then we don't have the frame version of this yet, but that's okay. Not reassuring, to say the least. So I'm not sure what the error is there. It could just be that we're not placing these things correctly or something similar to that, right? When we're actually creating these like blocks. It could be also that we are going, I don't know which way our stuff goes as things descend. I was assuming that y was going up, but maybe y is going down. I don't remember how we wrote this system. So that's one of those things that could easily do it. Let me just take a look here. It's you can see it here. It's going down like that. So I think when we get the dimensions of the profile rect and we do a y, but that is not correct. It's the maximum that we actually want, right? Oh no, I'm wrong. That's supposed to be the x first of all. The block y is the max y minus the block dim. That seems right. The block index here is getting incremented, isn't it? Oh, no, it's not. So that would also be a problem. Forgot about that part. So I think that's all good. We should probably also draw the block itself here. Just as like a gray, like backdrop thing, maybe like this. And then I'm going to step into this and just see why it's failing to produce any actual drawable regions. Okay, so kind of a little wonky what's going on there. But the block rect at least is drawing, it looks like it's drawing itself now. So I wonder if there's just something stupid that I'm doing here we've got a rect min dim, and it's going to draw this. It should be a quarter of the size of the profile rect. It didn't seem to be changing size, so that seems bad. Something seems a little bit busted there, and I don't know what. So we may have to step in there and see. We could make sure that we're passing the right size there, but but it looks like we are, right? So there's the layout elements bounds. So that feels like that should be fine. So I'm not sure why we're getting that kind of weird behavior. So let's step in there and take a look. Just get a feel for like what's actually being drawn. This is turning out to be a totally marathon session. So inside, I want to bring this up first so we can take a look at it. And I'm just going to go ahead and look at the arenas. So if I now set a breakpoint inside draw arena interval there, what's going on, right? So as we come through here, let's just look at what all our variables are, just so we know whether we're in complete nutso town or not. That seems reasonable, so long as our center, as long as the middle of the screen is 0, 0, which maybe it is. You know, I don't remember how we set up the coordinate system. That seems fine. That doesn't seem totally bizarre or anything. How big should each of our blocks be? Again, seems totally fine. Okay, so first of all, yeah, this is wrong because we're not offsetting by the profile rect corner. So that's definitely wrong. Let's see what else is wrong. That's probably not the only thing that's wrong, though. So let's see, the block rect. I mean, the rest seems, that all seems pretty reasonable, right? This arena apparently has no allocations in it whatsoever. That seems bad. How are none of these having any allocations in them? What? We must have some kind of a bug in there. Which arena is this, by the way? Oh, well, I take it back. The debug arena, that is what you would expect to see, because the blocks can't have any actual data in them, because it's suppressed. We should also not draw them. I was going to say, that's nuts, we did something wrong, but we didn't do something wrong. That's what's supposed to happen. Let me also, while I'm recompiling there, let me add the profile rect minimum corner. Just so we're offset properly. I don't think that's going to help, but oops. It'll at least center the thing properly. For now, I want to actually see what's being drawn before I start debugging. All right, so now we're at least properly sizing, but by properly, I mean it doesn't seem like we're ever actually advancing the block, though. So that's a little bit weird, right? Like this block index should be moving the rectangle along, and it does not actually appear to be. But I'm not sure why that would be. Yeah, I don't see it. So let's step through there and see why we're only drawing what appears to be a single rectangle, and it's the wrong size, right? So it's supposed to be a quarter of the size of the profile rect, but it's like a half the size. Although we could be drawing two rectangles only and then not drawing a third, which would produce what would amount to the same result. What I could do is outline these as well, which I probably should do. Something like this, so that they have a little bit of an outline around them, just so we can see whether or not that's happening. I don't know. We'll find out. Just make sure that's built. All right. So now we've got there's two of them that are being drawn, and then we don't know why, we don't know what else is happening. So we want to go now set that breakpoint and see why. So if I come in here, we start out with block index 0. We suppress this entire thing, so I guess I probably have to do this to get to the first unsuppressed one. We produce a block rectangle for this entire block. Looks pretty reasonable. The Z on this is wrong, so we should probably make these so they can draw over these, but that's a separate issue we haven't addressed yet. So this is not good at all, right? This rect min max, oh, wait a minute. So get barycentric does the opposite thing that I thought it did. So get barycentric actually computes the barycentric coordinates. I guess we don't have one that gives them back to us. Like when we put one in, we get back what the location would have been using that. That's okay. Again, the problem still is that our block recs are wrong, so I'm not so concerned about this part of it yet, but for what it's worth, it's a pretty trivial fix. We just want to do a linear interpolation here. We want to take the block rect min x, our t min, and the block rect max x, and then the min y. And maybe I'll do this just to make it a little easier to read. So that is the correct way to actually, oops, I don't know why it's still hanging around. That's what we were trying to do. I wanted to sort of do a bilinear, but I guess we don't really have that, so we kind of just have to make do, right? So I think we're fine otherwise. I feel like I could have used, we do have a V2 version of this, so I suppose I could have done that, but who cares? So finally, I think that was probably our problem, is why we weren't getting actual memory ranges drawn in there. But the problem, again, that we're going to have is that we're still, like, the block regions themselves looked wrong. And so we have to step through and find out what's going on there. I don't know what's happening there. So when we step through here, we should now have region recs that correspond more properly. Yeah, exactly. So that's much better. And then what we need to know is when we actually get down here, right, and we increment that, we should now see that block index changing, right? How many of why were so many of those suppressed? Did you see that? What's going on there? Hold on a second. How the heck is suppress set to 1 on the game mode? I must have done something stupid somewhere else too. I bet that's just garbage, right? Because we didn't fill it out. So that was also a bug. That was getting set to suppressed. Because we don't want to clear things in the debug system. We want them to be as fast as possible. So that was probably what was happening there. All right. Let's check it one more time. All right. This is kind of nonsense. I don't know what this is supposed to be. Or actually, that's kind of correct. Those would all be fixed size chunks. So now that's looking mostly correct, actually. I'm going to go ahead and change this back to regular build. I think we're pretty close. I'm going to probably call it a day now because we've done a ton of work, but I think we're at the point where we can now visualize our memory allocations correctly. Interesting. You know, this is going to be pretty cool once we kind of get it more dialed. Anyway, let me show you the thing I was actually trying to show you. So here's the layout of the world with the extra bloating in it, right? Those are all the world chunks. And what started us down this whole rat hole yesterday, where I was like, I want to visualize the memory, was inside the entity struct. I'm like, we want to start paying attention to this stuff. And I was just trying to make a point, but I was like, I don't have anywhere to visualize it. So this ground cover here, let's say we don't have ground cover in there. Right, so there's no storage for ground cover. And then I run this thing and I look at the memory visualization, right? Look at how big the block of memory is taken up by our entire world is, right? Remember that. What is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows, 11 rows long, right? I come in here and I add the ground cover into these entities, and now it's massive, right? It's like twice that size. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, right? Furthermore, we could just look at this number, right? It's 69 megabytes. And then we look in here, and it's 47, right? So just that one member is just way ridiculous in terms of its impact on our footprint. And that only goes up because every entity we add to the world would do it. And so I just wanted just to be able to show what that kind of a difference was, which kind of let us down here. But there you go. We will fix that visualization to be better later. Hey, the mouse is working on Linux today. That's a first. All right, let's go to an extremely brief Q&A because my throat is tired at this point. But now we've got the memory viz in there and we can make it better. Because right now it's not really proportional. So we kind of want that to be fixed. Not on topic at all, but could you just say hi to my friend Thomas Grimm, who is a fervent follower of yours? So Thomas Grimm is I feel like that is the kind of name that you want to be an author of gruesome children's books, right? I mean, that's what you always think of when you think of Grimm, like Grimm fairy tales. Do you write children's literature? Would be my very first question. And is it sort of somewhat gruesome? All right, no questions is good because we've been on here for a while. So I'm going to go ahead and close it down. All right. Thank you everyone for joining me for an episode of Handmade Hero, a very long episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow with the series at home, you can always pre-order the game on handmadehero.org. Comes with the source code. You could go make a better memory visualizer. We've done all the groundwork now. So that might be kind of a fun little challenge if you're interested, because like the one that we just threw in there, it's not even proportional to the size correctly. So like, although it divides stuff up per block, it doesn't divide stuff up for the total amount of memory being used. And so we're going to make a better one than that, to be sure. And you could beat us to it. You have all week to make some better memory visualizers in there using the data that's in there. Do something cool. I'll be back next week to do some myself, and we'll see what happens. Until then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.